Remember the Neanderthals? Our superstar humanoid cousins of the Pleistocene era in all their wide-nosed and slope-foreheaded glory? They roamed through Europe and Asia for over 350,000 years before they vanished. This was around the same time our ancestors, the Homo sapiens, decided to take a vacation from Africa and explore the world. We may never know what truly happened to the Neanderthals and why they didn't make it to the present times, but thanks to some hefty archaeological digging and impressive fossil finds, we now know a bit more about them. One theory for their disappearance is that the climate wasn't suitable for them anymore. Supporters of this idea think Mother Nature turned on the Neanderthals and sent them packing. Unfortunately, if we look at Neanderthal archaeological sites in Italy, for example, there are no signs of weather catastrophes that could have wiped out this entire species. Others believe there was a bit of resource competition between Neanderthals and humans. That's why specialists also dug around several other archaeological sites where Neanderthals and sapiens might have rubbed elbows for about 3,000 years. In this case, it does seem that the Neanderthals were a bit behind with their tools. Their technology was like flip phones in the age of VR. But who knows if these two species ever crossed paths in that particular region? The evidence is still fuzzy. How they went extinct isn't the only information we're curious about when it comes to Neanderthals. Other scientists, for instance, are trying to decode some of the Neanderthal molecular barcodes to identify their specific traits, some of which you might share, believe it or not. Sure, Neanderthals as a whole species did, in fact, go extinct. But that's not to say remnants of their DNA can't be found in humans. Now, you know how things go when folks live near each other. Some genetic mixing was bound to happen. The evidence? A dash of Neanderthal DNA which was found in modern folks. Now, this is where the plot thickens. Scientists thought that since Neanderthals never lived in Africa, their DNA wouldn't be found in modern African populations. Well, it turns out that African people have about 0.5% Neanderthal DNA too. This doesn't mean our Neanderthal relatives simply teleported through African territories without leaving any trace behind. What this discovery actually implies is that early humans might have visited Europe, mixed their genetic material with that of Neanderthals, after which they returned to Africa. That's a lot of migration. How did we stumble upon that Neanderthal DNA these days, you might wonder? Well, scientists gathered thousands of people from all around the world. Participants came from places like East Asia, Europe, South Asia, America, and Africa. Percentages may vary, sure, but around 20% of the good old Neanderthal DNA is still found in US modern folks. Sure, the average Joe only carries about 2% of that caveman swagger. If you're from certain places or families that have a smidge more Neanderthal in their gene soup, you're looking at 3% tops. Is there anything in particular that we share with our long-gone humanoid cousins? As it turns out, our Neanderthal ancestors gifted us more than just their company for some thousands of years. They also passed down the incredible legacy of their noses. Well, you see, the Neanderthals were outfitted with some seriously high-rising sniffers. These weren't just cosmetic, they were also quite the asset in chilly climates. The icicle-dripping, teeth-chattering kind of cold where your breath could freeze before it leaves your lips. During those days, the Neanderthal noses worked as personal heaters, warming and humidifying the cold, dry air they inhaled. For that kind of extreme weather, these impressive nasal skyscrapers turned out to be quite handy. When our Homo sapiens ancestors decided to leave the sunny savannas of Africa for a spot of frostbite up in Eurasia, they bumped into the Neanderthals. This encounter resulted in not just an exchange of pleasantries, but also an exchange of genes that coded for larger noses. This newfound genetic nugget was discovered by scientists who dug deep into the DNA of over 6,000 volunteers. To complete the study, these scientists meticulously compared this genetic data to snapshots of the volunteers' faces. They measured the distances between various points on each face, such as the height of the volunteers' nose bridges. They then played a game of spot the genetic marker to identify if certain facial traits were linked with specific genes. By the end of this exciting chase, they hit the jackpot. 33 shiny new genome areas were linked to facial features. One standout gene, named ATF3, was traced back to our Neanderthal ancestors and seemed to be the maestro of controlling nose height. Participants with Native American ancestry had Neanderthal hand-me-downs in this gene, contributing to their taller noses. Think of the ATF3 gene as a Neanderthal housewarming gift to us humans as we stepped into colder climates from Africa. Interestingly, this isn't the first time our ancestors have played pass the gene. Back in 2021, the same research team uncovered a gene influencing lip shape called TBX15. This gene was a little love note from the Denisovans, another set of our ancient relatives, who lived in Asia and went extinct around 30,000 years ago. Another part of the scientific community believes our Neanderthal buddies had this weird genetic feature when it came to their brains. Is that why they didn't make it? Through this theory, it was suggested that US humans might owe our brainy edge to a quirky gene mutation. This mutation gave our neocortex, that's the smarty pants part of the brain, a little population boom in the neuron department. This amazing gene of ours isn't all that different from the Neanderthal version. It's just one amino acid off, just like ordering a coffee with one sugar instead of none. This tiny tweak is found in virtually all modern humans. Meanwhile, our extinct relatives, the Neanderthals, Denisovans, and other primate pals, all missed the mutation memo, at least according to the study. Now, let's not get ahead of ourselves. Just because we have more neurons doesn't necessarily mean we're geniuses by comparison. But these results do suggest that we might have rewired the brain in a way that gave us a cognitive leg up. Also, it's not all about this lone amino acid difference. It's just a piece of the puzzle. Scientists have previously found a whopping 96 differences between our DNA and that of Neanderthals that could have potentially affected our different outcomes as species. Studying Neanderthal DNA also gave us some insight into their relationships. In fact, we now have some solid evidence of what a Neanderthal family looked like. And surprisingly, it's not really that different from ours. For this study, researchers gathered information from a Neanderthal archaeological site located in Asia. They discovered that one particular family included a doting Neanderthal dad, his teen daughter, and a sprightly young lad who was possibly their nephew or cousin. Part of the group was also an older female relative, maybe an aunt or granny. Now, our young damsel would eventually pack her bags, wave a teary goodbye, and leave her papa's home when she found Mr. Right. Had she been a boy like her young cousin, she would have been a happy homebody. But worry not, she wasn't stepping into a world of strangers. Her new community likely had some familiar, friendly faces. But how were scientists able to predict the ending of this story? By browsing through their gene pool, researchers were able to figure out that the Neanderthal social structure was patrilical. What this means is that most female Neanderthals left their homes when choosing a partner and started a new life with another family. The same research shows that our cave-dwelling clans likely weren't living in isolation either. Families living close by were probably visiting the same rock sampling areas to make their stone tools, the equivalent of a neighborhood hardware store. And when they weren't tooling around, they were busy hunting delicious meals like ibex, horses, bison, and other wandering critters. Scientists, however, were careful to add that this ancient family portrait might not represent the full spectrum of Neanderthal social life. They've kindly asked future archaeologists to get more Neanderthal DNAs on the Ancestry websites.
If you are one of those folks who can stay up all night and doesn't fancy early wake-ups, you might have some early human Denisovan DNA in you. Now, don't worry, those guys, who were closely related to the Neanderthals, were pretty cool, and it looks like we've got to thank them for inventing fashion. Plus, if you do have Denisovan DNA in you, you could be better adapted to living at high altitudes, have extra muscle strength and endurance, and a stronger immune system. Scientists first discovered Denisovans in 2008 when they found a small piece of a finger bone in Denisova Cave in the Altai Mountains. They learned that the bone belonged to a little girl who was between 5 and 7 years old when she passed away around 40,000 years ago. The cold weather in the cave kept the bone in excellent condition. A couple of years later, another team of researchers managed to extract DNA from the find. They compared it to the DNA of modern humans and another ancient human species, Neanderthals. Her DNA was similar to both, but it was also different enough to show that she was part of an entirely new species of humans. No one had known about this group before. They decided to name it Denisovans, after the cave where they found her tiny finger bone. Later, they discovered 3 more Denisovan fossils, including some teeth, also inside the same cave. Scientists also found Denisovan fossils in caves in China and Laos, and one jawbone with teeth on the Tibetan Plateau, over 10,000 feet above sea level. Scholars used a technique called uranium series dating on the mineral stuck to the bone. They discovered that it was 160,000 years old. It proves that Denisovans lived at high altitudes much earlier than anyone thought ancient humans could. For comparison, Neanderthals rarely went higher than 6,000 feet. Scientists had already found a special gene in Denisovan DNA that helps people survive in low-oxygen environments. But the Siberian cave where Denisovans lived was only 2,300 feet above sea level. Today, many people living in high places like Tibet, including Sherpas and other local groups, have this same helpful gene. It likely entered their DNA thousands of years ago when Denisovans and modern humans mixed. Because this gene made it easier to live in thin air, it became very common in those populations over time thanks to natural selection. It looks like the Denisovans also had wider skulls than those of us or Neanderthals. They also appeared to have no chin. They did have sloping foreheads, long faces, and large pelvises like Neanderthals, and a large dental arch like modern humans. Denisovans had narrower lips and shorter yet wider noses than modern humans. The scientific community still doesn't know where the Denisovans came from, but one theory says they were ancestors of Homo erectus. Those were the oldest known early humans who had modern human-like body proportions, with elongated legs and shorter arms compared to the size of the torso. About 700,000 years ago, some of them traveled from Africa to Eurasia, probably not by bus. These travelers were like the great-great-great-grandparents of the Denisovans and the Neanderthals. Scientists believe that these two groups split up, both in where they lived and in their DNA, around 370,000 years ago. The Neanderthals moved west and settled in Europe and some parts of Western Asia. They lived everywhere, from the Atlantic Ocean in Europe to the Altai Mountains. The Denisovans went in the opposite direction, east into East Asia and Southeast Asia. They even traveled to places like the Philippines and Papua New Guinea and crossed the Wallace Line, which separates Asia from Australia. Researchers have found Denisovan DNA in the genetic code of modern humans from Australia and Melanesia. It's a region in the southwestern Pacific Ocean from Papua New Guinea to the Fiji Islands. Now, it's also possible that you have Denisovan DNA if you come from East Asia, although it's less likely. Central and South Americans also have something Denisovan in their genomes. If you want to be sure, you can take a genetic test that will show the exact percentage, if any. Now, Neanderthals and Denisovans lived in places far from the equator, where the amount of daylight changes a lot with the seasons. Modern humans originally lived closer to the equator, where the length of day and night stays almost the same all year. Scientists think that these differences might have influenced how our internal clocks, called circadian rhythms, evolved to help us wake up, go to sleep, and feel energetic at the right times of the day. In 2017, researchers found that some of the genes that affect how people sleep are linked to latitude, how far north or south someone lives. These genes might have helped ancient humans living in northern areas adjust their body clocks to the changing seasons. Scientists studied DNA from 3 Neanderthals, 1 Denisovan, and 1 modern human. Neanderthals and Denisovans who lived in high-latitude areas, where the amount of daylight changes a lot, had genes that helped them adjust to those light cycles. Modern humans in Africa didn't need those same adaptations because their days and nights stayed more consistent. While modern humans, Neanderthals, and Denisovans had children together, some of their descendants inherited Neanderthal genes that made them more likely to be morning people. Scientists think this wasn't just an evolutionary advantage, but rather a way for their body clocks to adjust more quickly to the changing light in high-latitude regions. A faster internal clock might have helped them wake up and go to bed earlier, which made it easier to adapt to new light patterns. The researchers only studied DNA from 4 ancient humans, and it's hard to tell if these changes in circadian genes were only because of light cycles or also due to other factors, like temperature. Another thing Denisovans probably left behind is fashion. Now, researchers discovered the world's earliest sewing needles with tiny holes for threading in Denisova Cave. These needles date back to the last glacial maximum. Before these fancy needles, people living in the cave used simple tools called bone awls, which didn't have holes for thread. These were fine for making basic clothes, but when the weather turned freezing during the Ice Age, they needed better tools to create more layers of clothing to stay warm. The Denisovans designed the first eyed needles to stitch together more tightly fitted clothing that could trap heat better. These needles were a big step forward because they allowed for fine sewing that could make their clothes not only warmer, but also more comfortable and durable. Plus, clothes became a way for them to express themselves. Before the Ice Age, people showed off their creativity with body paint and other marks. But when they started covering their skin with clothes to stay warm, they lost those canvases for art. So they began to decorate their clothes instead. Using eyed needles, they could sew beads, fur, and other materials onto their garments and turn simple clothes into works of art. Perhaps it was the beginning of bling. Denisovans sound too good to be true, but they might have passed over one mean gene to you. It helps move zinc around in our cells, and this gene was especially helpful to our ancestors who lived in cold places because it helped them survive the frost. But if there's too much or too little zinc in the body, it might make you predisposed to mental health issues. This gene originally came from people in Asia, but over time it spread to people in Europe, the Americas, and all around the world. Scientists are still trying to figure out why the Neanderthals and Denisovans disappeared, while we, Homo sapiens, survived. The DNA of our extinct long-distance relatives showed that they lived in small groups and often had families within those groups, which might have caused some problems. Our ancestors live in bigger groups with more people and had genetic diversity. This means that there was a mix of traits that can help stay healthier or adapt to changes in weather. Neanderthals and Denisovans didn't have this advantage. Another thing that helped Homo sapiens was the wide social networks that allowed them to share new ideas and tools. So Denisovans probably just couldn't handle the big changes on Earth and adapt to new habitats and disappeared. Throughout time, scientists have managed to uncover about 6,000 early human fossils, ranging from skulls to teeth. For some of these fossils, it was a breeze. Researchers could instantly identify them as belonging to, say, the Neanderthals. However, when it came to others, things got a bit trickier. Some fossils just didn't fit into any existing categories. So, what categories of prehistoric humans do we actually know about? Well, up until recently, we recognized 8 different species of early humans. One of these is Homo habilis, which means handyman. You'll recall that Homo is Latin for human. They resembled regular primates, but were pivotal in our evolution. They were the first to create stone tools, which significantly aided their daily activities, such as butchering. Next up, we have Homo rudolfensis. These guys were larger than Homo habilis and boasted bigger brains, but they were still quite distant from modern humans. For example, even though the neurological structure of their brains was becoming more complex, they were probably not capable of using any form of actual spoken language. Then came Homo erectus, the first to walk upright, followed by Homo antecessor, which is considered the last common ancestor of modern humans and Neanderthals, along with a host of other Homo species. Meanwhile, we're still piecing together the story of the enigmatic Denisovans. Our knowledge of Homo naledi is pretty limited too, since it was only discovered in 2013, and it is species number 8. Interestingly, Naledi means star in the Sotho language because they were found in a cave called Rising Star. Scientists were taken aback by them. Everything suggested they were around 2 million years old. But after closer examination and some tests, it turns out that the Naledi species is much younger, between 236 and 335,000 years old. Their hands were adapted to making tools, yet no tools have been found nearby. Long story short, they're a puzzling species, and there's still so much more to learn about them. So even though today we have only one human species on our planet, Homo sapiens, we continue to discover ancient species that are long gone. Now, you might wonder why researchers study these extinct species. The truth is, they need this knowledge to piece together the intricate narrative of our prehistoric past. In 2024, a significant discovery emerged, the ninth human species, named Homo giluensis, which translates to large-headed. Researchers suggest that this species hunted wild horses, crafted stone tools, and processed animal hides to survive harsh winters. A researcher from the University of Hawaii noted that the discovery of this potential new species came about while his team was developing a novel method for classifying fossil evidence. Interestingly, one potential representative of Homo giluensis isn't entirely new to science. The Denisovans, first identified in 2010 through DNA analysis of a finger bone found in Siberia, have yet to be classified as a distinct species. Some scientists propose that they may actually belong to this newly identified group. These big-headed individuals could help shed light on the long-standing mysteries surrounding these hominin fossils, which have puzzled researchers due to their mixed characteristics of Homo erectus and Homo sapiens. You see, sometimes it's tough to call a spade when you don't even know what a spade looks like. You get the idea? Many unsolved mysteries linger, simply because scientists haven't had this crucial, big-headed piece of the puzzle. So theoretically, we modern humans could also be considered a bit of Homo giluensis. You don't believe me? Well, watch this. We need to consider two key facts for this equation. First, there are the Denisovans, a group we might refer to as Homo giluensis from a scientific perspective. Yeah, this is just a theory proposed by some researchers, but let's roll with it for now and pretend it's a fact. Second, it's important to know that the Denisovans interbred with the ancestors of modern-day Melanesians. These folks inhabit areas ranging from New Guinea to the Fiji Islands and carry between 4 and 6% Denisovan DNA. Now, you might not personally have those genes, unless you've been tested, of course, but the key takeaway here is that there are modern humans today who share genetic links with the Denisovans, or Homo giluensis, or big heads if you prefer. Now, that all sounds pretty plausible. Let's unpack step by step how it happened. Researchers have uncovered this type of ancient human, known as the Denisovans, based on skeletal remains found in Siberia. These ancient humans coexisted and interbred with modern humans, adding yet another layer to our understanding of human evolution. Named after the Siberian caves where their fossils were discovered, the Denisovans are believed to have roamed widely across Eurasia. Evidence indicates that the Denisovans lived alongside Neanderthals and interacted with early Homo sapiens, possibly around 50,000 years ago. A team of scientists successfully sequenced a complete genome from these ancient hominins using nuclear DNA extracted from a finger bone. This discovery reveals that at least 4 distinct human groups existed during the time when anatomically modern humans began migrating out of Africa. Alongside modern humans and Neanderthals, we now have to consider the Denisovans and another small human species from Indonesia, often referred to as the Hobbit, when discussing our evolutionary history. One intriguing question that arises is why Denisovan genes are predominantly found in modern Melanesians, yet absent from other Eurasian populations. Remember that 4 to 6%? One hypothesis suggests that interactions between the Denisovans and early modern humans were limited and brief, especially as humans migrated throughout Southeast Asia into Melanesia. Scientists speculate that only a small number of the Denisovans may have interbred with a larger group of modern humans. This could explain how the Denisovan genes made their way into the gene pool despite the likelihood of infrequent encounters. Anyway, the more scientists dig into our past, the more fascinating things they uncover about our ancestors. Take Neanderthals, for example. Did you know these guys were responsible for creating the very first piece of art ever? I had no idea. But a 2018 study of ancient cave art in Spain revealed what are now considered the oldest known artistic creations. We used to think Neanderthals lacked the cognitive skills needed for art, but it turns out they were actual art pioneers. Not only did they create art, but they also seem to have invented hashtags thousands of years before Chris Messina did it in 2007. Right, I'm kidding, but you'll soon get why I mention hashtags. The artworks found in several caves in Spain include simple hand stencils, a ladder-like drawing, and various other markings. Until recently, these prehistoric pieces were believed to have been made by early humans. But new testing methods suggest they're much older than we thought. Above all, the earliest recognized Neanderthal artwork, which looks like a hashtag, was discovered in Gibraltar back in 2014. To determine the age of these artworks, scientists employed advanced dating techniques using eHarmony and Match.com. Oops, wait a minute, wrong dating techniques. They actually used uranium and thorium radioisotopes instead of the traditional carbon dating. Once the necessary tests were completed, they confirmed the art was approximately 65,000 years old, 15,000 years older than the previously oldest known art from Indonesia. At that time, the only species around were Neanderthals, so it's safe to say they were behind these creations. Modern humans didn't arrive in Spain until about 20,000 years later. Hey, it was a long commute. That rules them out as the hashtag creators. The hand stencil was likely created intentionally, with the artist preparing the pigment and applying it over their hand. Plus, the caves also contain a collection of painted seashells that are an astonishing 115,000 years old. Some of these shells have been drilled, suggesting they might have been used as jewelry. Some specialists argue that the fact Neanderthals created art hints that they might have also had some form of spoken language. So maybe it's time we fully embrace Neanderthals as part of our lineage. They're humans too, just a different branch of our family tree. While these findings are intriguing, some experts remain skeptical about the new dating methods, claiming they're not entirely convinced. Hey, what do you think? Share your thoughts in the comments. You run through the night forest for more than an hour. You're even faster than a cheetah. You're not tired or cold. You hear a mouse rustling in the roots of a tree and catch all the smells of the forest. With night vision, you see a bird in the night sky. You can go for months without food or water. Gills allow you to swim underwater freely. This is how evolution made humans in a parallel world. Here, they're ideal organisms prepared for anything they might meet in the wild. In our world, things are more complicated. We evolved, but didn't always get stronger. Humans only survived because they adapted and changed the world around them. A human only has 32 teeth. When they fall out, they no longer grow. But evolution doesn't stop. Our food has become softer and more nutritious. You don't need to chew it for a long time. New diet reduced the jaw and enlarged the brain. As a result, there's no room left for the 4 teeth that are closest to the joint. We call them wisdom teeth. In the future, we'll only have 28 teeth. And even today, 35% of people don't have the wisdom teeth. Homo sapiens is the only mammal to have a chin. This is the protrusion along the lower edge of the jawbone. Even our relatives, gorillas and chimpanzees, have their jaws slanted inward. Anthropologists think that the chin is a result of reduction of human face. Perhaps in the past, the chin supported our powerful jaw and enhanced our strength. Over millions of years, the face has shrunk, but the chin has remained. Put your hand on a flat surface, connect your ring finger and thumb, bend your wrist, and you'll see the palmaris longus. 15% of people don't have this muscle already. It doesn't affect the grip strength and has lost its meaning today. Millions of years ago, it allowed our ancestors to deftly climb trees. Evolution deprived us of this useful skill, but the remainder of it remained with us. Dogs, horses, monkeys, and many other animals can move their ears. This allows them to hear better and communicate with each other. Humans have a long, flexible neck, and evolution has left them without this ability. Still, 20% of modern humans can do it. This is another reminder of a time when we weren't much different from other animals. 10% of people have a Darwin's tubercle in their ear. In the past, we had pointy ears looking like the modern macaw's ones, and this little bump is the proof. When an emperor penguin hatches eggs, it doesn't eat for 115 days. Scorpions can stay hungry for a whole year. Evolution hasn't given humans a camel-like hump of fat or the ability to hibernate like a bear. Every morning our ancestors woke up and fought for their survival. We need a lot of energy for this, so we have to eat every day. This isn't very convenient, especially when your food isn't sold in a supermarket but runs away from you through the forest or field. In the human brain, at any given moment, 100 billion neurons work. Thanks to this, you have a good memory and can talk. This is essential for survival. A big brain has a flaw. For neurons to work, it needs a lot of fuel. It makes up just 2.5% of body weight, but consumes 20% of its energy. In 2 hours of playing chess, a grandmaster burns 560 calories. A professional tennis player will spend the same amount of energy in a single hour. Big brains make us weak. Even a small chimp is much stronger than a human. Why do you need muscles if you no longer swing from branches? But you need a big brain to negotiate and cooperate with other people. Got weaker, and we like lying on the couch more and more. This is a comfortable position for thinking. At night, our ancestors were especially vulnerable. When you sleep in a new place, the left side of your brain is more awake than the right one. This brain reaction is called the first night effect. This is an ancient reaction of the body to the dangers that awaited a human in the dark. 40 to 60 million years ago, evolution gave us yet another fear. We're born with the fear of being bitten by a snake or spider. Apparently, these animals were the main danger to the first primates. Anthropologists say we became runners 2 million years ago. Broad shoulders make it convenient to swing your arms and keep balance. A special ligament extends from the spine to the back of the head. It stabilizes the head while running. No primate has strong gluteal muscles. They only turn on to full power when you're running. Hairless and 3 million sweat glands keep our bodies from overheating. People are perfect runners, but evolution has made us slow. You'll never overtake a chimp on a short distance, and that's not mentioning cheetahs. They accelerate to an incredible 70 miles per hour. But almost all land animals are sprinters and don't run for more than 10 to 15 minutes. Humans are adapted for long distances. Walking 2 legs helped our ancestors solve many problems. They freed their hands to carry food or tools. 2 legs and a straight back made our ancestors larger and even scarier for other animals. When you stand on 2 legs, you'll quickly see a saber-toothed tiger, which is waiting for you in the tall grass of the plains or the African savanna. Your body weight is distributed over only 2 limbs, and this has consequences. You can calmly walk down the street, stumble, and get injured over that. Consider this our payment for upright walking. So why do we need toes? Certainly not to hit them on the furniture. When our ancestors lived in the trees, toes helped them cling to branches. Imagine you can work at the computer, draw pictures, or cook scrambled eggs, all with your feet. Cool, but good old evolution has deprived us of this skill. Today, we're not sitting in the trees, but our feet remain flexible. Come to think of it, hooves would be more suitable for us. They're durable and don't need shoes. But until we evolve again, our feet remain fragile. Either of them has 26 bones. This doesn't make our walking or running any safer. You go to the cinema, take your popcorn basket, and start munching on it in anticipation of a great couple of hours. But then you start choking. Those few minutes of coughing and involuntary tears seem to last forever. The human is the only mammal that can choke on its food. We can't eat and breathe at the same time. The reason for this is the structure of our vocal apparatus. Your larynx is down below, thanks to which you can talk, but not while eating. Goosebumps, horripilation, gooseflesh, these are the names of the reflex that makes your skin not smooth but bumpy. This happens when you're cold or scared. Greetings from the Stone Age. Our ancestors were covered in thick hair. When they got scared, the hair follicles rose. This made them large and menacing for other animals. This natural reaction warmed the body as the air grew colder. The body of modern people no longer has long and thick hair. But if that movie is really scary, Or you forgot your jacket in the evening, goosebumps still appear. Bears, hedgehogs, bats, some turtles, fish, and insects. All these creatures have one thing in common: they hibernate. Scientists claim that our ancestors were also on this list. In a cave in the north of Spain, researchers found fossilized bones of ancient people. The analysis showed that 500,000 years ago, humans could spend several months hibernating, similar to bears. Thanks to this, they survived Ice Age. Wow, how I miss this skill. Our eyes allow us to see dust in the air and huge mountains on the horizon. We see the world in color and recognize each other's faces. And when it gets darker, our vision quickly adapts to new conditions. But we don't see well in the dark. Evolution hasn't given us the sight of a tarsier. This primate is the size of a baseball and can see perfectly in the dark. Tarsiers could easily catch a beetle flying through the night forest. Still, I wouldn't want my eyes to take up most of my face, and beetles are actually not among my favorite after-dark snacks. How about you?
You're way more Neanderthal than you think, at least when it comes to your DNA. These ancient hominids were shorter and stockier than humans today. They made stone tools, used fire, wore clothing, and had some rituals of their own. The official theory says that they went extinct 40,000 years ago, but a new study says Neanderthals probably never really disappeared completely, but could have mixed with modern humans. It looks like every modern human has about 3% of the Neanderthal genome in their DNA. If it's accurate, it means Neanderthals were more connected with our ancestors than we previously thought, and shared a long history of living together. Neanderthals were very close relatives of modern humans, but our families separated about 500,000 years ago. More than 10 years ago, scientists discovered that Neanderthals had families with the early humans who traveled out of Africa. Because of this, people living outside of Africa today have about 1 to 2% of Neanderthal DNA in their genes. We now have only 3 really good examples of complete genetic code from these ancient hominids. The first one comes from bones found in a cave in Croatia that are 50,000 to 65,000 years old. 2 more examples, which are about 80,000 and 50,000 years old, were found in caves in Eurasia. Scientists still aren't sure as much about how modern human DNA got into the Neanderthal genetic alphabet, because they don't have enough material to study. But they did compare the existing DNA of 3 Neanderthals with the DNA of 2,000 modern humans. They found that the Neanderthal DNA might be made up to 3.7% of modern human genetic code. It means that in the ancient Neanderthal population, about 1 in 30 parents were modern humans. The scientists found that modern human DNA got mixed into the Neanderthal genetic alphabet during at least 2 periods when humans and Neanderthals were interbreeding. This happened once about 200,000 to 250,000 years ago, and again about 100,000 to 120,000 years ago. There might have been other times they mixed, but we can't see those in the DNA we have now. Another recent study, which hasn't been fully checked by other scientists yet, says that most of the Neanderthal DNA in modern humans came from one big period of mixing, about 47,000 years ago, that lasted for almost 7,000 years. Scientists found skulls that are about 100,000 years old in 2 caves in the Middle East. These skulls look like they belonged to early modern humans, but have some features like bigger eyebrows that might show they had Neanderthal DNA. This could be because of gene flow from Neanderthals, and it fits in the mixing time frame. The study also looked at the genetic differences in the 3 Neanderthal genomes and found out that Neanderthals had an even smaller population than scientists thought before. It could be another proof that Neanderthals didn't just go extinct, but became part of the modern human gene pool. Many groups of modern humans left Africa and mixed with Neanderthals so much that Neanderthals couldn't stay separate. In the future, scientists want to study how modern human DNA affected Neanderthals. This could help us understand if this mixing had good or bad effects on Neanderthals. Neanderthals aren't our only relatives from the past. There used to be at least 9 species of humans on our planet. One of them, Homo habilis, earned the nickname handyman because stone tools were found with its remains. It lived in eastern and southern Africa. This early human had a slightly larger brain than its older relatives and an ape-like face. Homo habilis was about 4 feet tall and ate a variety of foods. For a long time, scientists thought Homo habilis was the oldest member of our human family. But new dating methods have shown that Homo erectus, another ancient human, might be older and not related to Homo habilis. Homo naledi is a more mysterious member of our human family discovered in a South African cave in 2013. It's the only region of the world where their remains were found. They walked on 2 feet but were also good at climbing trees. They were small, about 4 feet 9 inches tall, weighed around 88 pounds, and had small brains. We don't know much about how they lived since we haven't found stone tools or other cultural evidence. But some scientists think they might have buried their deceased and made cave art. In 2010, scientists found some fossils in a cave in Siberia, but they weren't sure what species they belonged to. These fossils are from a group called the Denisovans, who lived between 194,000 and 51,000 years ago. We don't know much about them because we only have a few fossils, but DNA analysis has shown that Denisovans were closely related to Neanderthals and modern humans. They even had families with early humans, especially in Southeast Asia. There aren't enough fossils to give Denisovans their own species name, but their genes are found in modern humans, which means they might be part of our own species. As scientists study more about Denisovans and fossils in Southeast Asia, we might understand better how different species fit into the Homo family tree. In 2003, they found fossils of a very small human-like species in a cave on the island of Flores in Indonesia. These tiny people lived between 100,000 and 50,000 years ago. They were only about 3 feet 6 inches tall. Scientists think they might have come from another species, Homo erectus, and became smaller over time because they lived on an island with limited food. Because of their small size, they're often nicknamed hobbits. Around 40,000 years ago, Homo sapiens, yep, that's us, were the last humans left out of many different kinds of human-like species that walked on 2 legs. So, the logical question is, what happened to the others? And what did we have to do with their disappearance? Some scientists think we survived because our offspring lived longer, or because we were better at handling changes in the weather. Others think we might have competed with other human species, or maybe mixed with them and shared genes. About 300,000 years ago, the first Homo sapiens lived in Africa. They didn't look exactly like us, but they were more similar to us than other early humans. They had tall, round skulls with almost straight foreheads. Unlike Neanderthals, they didn't have thick brows or jutting jaws like Homo naledi. They also had chins, which no other early humans had, though we still don't know why. Homo sapiens lived in bigger groups and had more genetic diversity compared to other early humans. This helped us in many ways, not just in staying healthy. Having big social networks across different places was like having a safety net. If we ran out of food or water, we could go to other groups we were connected to, and they would help us because we weren't strangers, we were family. These big networks also helped these early humans share new ideas and inventions. A big simulation showed that later species of humans could live in many different environments because of these wide networks and the ability to adapt. We know that Neanderthals were really smart, but Homo sapiens might have been just a little bit smarter. Small inventions like weaving and sewing needles could have given Homo sapiens an edge. Scientists have found evidence of weaving from 35,000 years ago and sewing needles from 30,000 years ago. Weaving lets you make things like baskets and nets to catch food. Sewing needles help you make better clothes and tents, which keep you and your youngsters warm and safe, which is very important for survival.
We people used to have real superpowers. But they all disappeared long ago because these abilities became useless and evolution took them away. For example, one of these superpowers was hibernation sleep. Yeah, it doesn't sound as cool as teleportation or flying, but in the modern world, it would be helpful. Imagine that you go to bed before winter and wake up in the spring. No cold weather, no spending money on food at this time, just a long, deep sleep. So perhaps our ancient hominin ancestors, more like primates than humans, could fall into a long hibernation. It was about 500,000 years ago, hundreds of thousands of years before the appearance of the first Homo sapiens. Hominini of that time lived in caves during the Ice Age and fell into a long sleep to survive. However, this is not a confirmed fact, but scientists have some guesses about it. Paleontologists discovered many fossils of our ancestors in one Spanish cave. The analysis showed that hominini lacked vitamin D and fat reserves. These strange indicators showed that the inhabitants of these caves could be in a state of hibernation. Perhaps their metabolic processes slowed down and their fat and vitamin reserves were depleted to support life during a long sleep. Of course, such an ability could be useful in the modern world, but it has several disadvantages. Let's look at the example of bears and what problems they can face during hibernation. Unique metabolic processes support their long sleep, but if these processes are violated, then after waking up, the bear can get very sick. This may happen because of an insufficient amount of fat and food reserves. Another ability from the past would help save thousands of dollars for modern people. This ability is strong and healthy teeth. Today, we have dental clinics, high-tech equipment, hundreds of types of toothbrushes and toothpaste, mouthwashes, and much more for the health of our teeth. Despite this, ancient people had stronger and healthier teeth. More powerful jaws and sharp teeth allowed them to chew on hard meat, and the immunity of the oral cavity didn't allow bacteria to develop. But then, agriculture appeared. People started to eat grains. This added new species of bacteria to the oral cavity, weakened the jaw muscles, and provoked cavities. Teeth became more fragile, but they got the most severe blow when people discovered sugar. Sweets added a lot of problems to teeth health. Previously, teeth worked as a tool for processing hard materials, but then we began to eat soft food, meatballs, and fried chicken, and the strength of teeth became meaningless. Evolution took that away from us. Our ancestors were taller, stronger, more agile, and more resilient than we are. A couple of days spent in the fields while hunting mammoths were the equivalent of a month of regular training in the gym. People were not obese. They ate natural food and looked like athletes. But why were they taller? What influenced bone growth? Over the past 10,000 years, the changes in growth were most noticeable. But this trend has changed in our direction in the last few centuries. People have started to get taller. It's difficult to determine the exact cause of such changes. It can be genetics, environment, lifestyle, nutrition, or modern technologies. So, 40,000 years ago, Cro-Magnons hunted and gathered in Europe. They were better developed physically, thanks to this lifestyle. Their ancestors migrated to Europe from Africa, which was the reason for the tall growth. Longer bones were helpful for adaptation to the hot African climate, but after 30,000 years, the growth of people sharply decreased because of the onset of cold weather and the development of agriculture. Our ancestors went through times of famine, and their bodies shrank over time to adapt to a meager diet. In addition, living next to livestock provoked the emergence of new diseases. All of it affected the appearance of ancient people. There are almost no such problems now. You can eat healthy food, receive medical care, and take vitamins. All this allowed us to grow a few inches taller. But one change in the human body still remains a mystery. We have the most advanced civilization in history today. People become professionals in neuroscience and thermonuclear physics, create powerful computers, have access to all the knowledge in the world, and study the boundless depths of space. But for some reason, our brains have become much smaller than those of people who lived several thousand years ago. But how is this possible, given that people were engaged in agriculture, trade, and the manufacture of simple tools in the distant past? Then big cities, architecture, art, and technology began to appear. And all this time, our brain was shrinking, while humanity was moving forward. It lost a piece equal to 4 ping pong balls. The reason is not that people were more intelligent in the past. The volume of the brain is not related to intellectual level. It's possible that people's brains have shrunk because of collectivity. To understand what that means, let's take a look at ants. Scientists measured the brain size of some species. They saw that species participating in complex social systems had smaller brains. This means that if an ant interacts closely with other ants, sharing work with them, its brain decreases. Sharing duties with other species contributes to brain shrinkage. Its cognitive abilities are distributed among different groups performing different jobs. It seems like a brain unloads its working and thus becomes smaller. That is, if you live alone on an island, do agriculture, fish, and build a house alone, then your brain becomes bigger. But in a large society, where all these activities are distributed among many locals, the human brain is shrinking. In a sense, intelligence becomes collective. And at what point in time did human intelligence become as collective as possible? When writing appeared. It appeared about 2,000 years before the beginning of brain shrinkage. When people learned to write, they freed up a large memory area in the brain. They didn't have to keep all the necessary things and ideas in their minds. With the development of civilization, the collectivization of humankind grew. And then there was TV and the internet. We will discover how this affects our brains in the future. On the one hand, the volume may decrease even more, but on the other hand, we're surrounded by an endless stream of information. We don't know yet how it will affect the size of the brain. The collectivization of consciousness is only one of the hypotheses according to which our brain has increased. Another theory says that this happened because of the home lifestyle. The brain of a dog, cat, or other pet is smaller than their ancestors who lived in the wild without a human. When people started living in cities and spending less energy on getting food, their brains could also begin to shrink. In addition to the size of the brain, people have undergone many changes. Humanity now shows a huge variety in appearance, which the early Homo sapiens didn't have. In the distant past, they possessed the same physical properties characteristic of a particular region. For example, a short and stocky build was typical for people living in cold conditions. The body area of a small person helps to keep warm better. Also, the body area of a tall person gives off heat more efficiently, so people in warm African regions are taller. And in places where it's scorching during the day and frosts come at night, people can develop the ability to lower their body temperature without feeling cold and shivering. This phenomenon concerns the Australian native tribes living in the central desert. The environment affects external characteristics almost as well as genetics. And over the past 40,000 years, the speed of evolution has increased. The ability to travel and the growth of the people population contributed to the mixing of different ethnic groups across the planet, which also provided diversity in evolution. It seems like humanity still comes to the highest point of our evolution, and perhaps there are no limits to that.
Whoa, there could have been more human species throughout history than we used to think. In one place in East China, Hualongdong, scientists found the remains of a human who lived around 300,000 years ago. They found a jawbone and parts of the skull. They carefully studied these bones to compare them with the bones of other ancient and modern humans. The remains themselves weren't that unusual. We know our human family is really diverse and has been around for millions of years. You know our ancient relative called Australopithecus, right? These fellas lived in different parts of Africa, and they were known for walking on two legs, just like modern humans. But their brains and some other parts of their bodies made them more similar to apes. Their teeth are a good example of how they were like a mix of apes and modern humans. Their canine teeth were smaller than those of apes, but their back teeth were still larger than ours. There were different types of them. You can recognize some Paranthropus because of their big jaws and teeth. One of the most famous fossils of Australopithecus is Lucy, a lady that's about 3.2 million years old. She was found in Ethiopia. So, we know that our family got pretty big from that point, or probably even before it. But it's always great to welcome some new members, which seemed to be the case with this new discovery. Some parts of these bones look similar to the bones of ancient humans, while other parts look more like the bones modern humans have. For example, the person whose bones they found didn't have a real chin. That means we can't put it in any of the groups we know of, like Neanderthals, or maybe even Homo sapiens. So, might we be missing a branch from the human family tree, or an important step in our evolution? What we're looking at here could be some mix between the creatures that became modern humans like us, and the ones that turned into what we today know as Denisovans. It takes time to figure it all out, though. We hadn't known much about Denisovans either, until we found some of their bones in a cave in the mountains. These bones are really rare, and we only had a few pieces to analyze, but their genes told us a lot more about their past than their fossils. Different kinds of humans lived on this planet, but through time, they spread around. One group started living in Africa. Those are our kind, Homo sapiens. Another group went to Europe. That's how we got Neanderthals. But some of these ancient human groups moved all the way to Asia. That's where we can trace a new interesting kind, Denisovans. It seems they're cousins to both modern humans and Neanderthals. The three species actually shared a common ancestor about 765,000 years ago. It's still not clear why Neanderthals and Denisovans took different paths, but one theory says that it was mostly because the Arctic ice sheet expanded southward all the way to the Black Sea, cutting off Europe from Asia. Life, or better yet, the planet, kept them separated for a very long time. Plus, they kept changing places where they lived all the time, always looking for something better, like every other human species before and after them. But this didn't last forever. Scientists found genes from two groups of Denisovans, one in mainland Asia and the other in a place called Melanesia. So not only did they have different groups within their populations, but it also seems that after thousands and thousands of years of developing independently, the members of these three populations, Neanderthal, Denisovans, and modern humans, somehow met again and spread all across the land. 5% of the Denisovan genome lives on, not in the area where scientists found their bones, but in people that live thousands of miles away in Southeast Asia. For instance, in Papua New Guinea. But scientists believe that the cave where they found the remains of Denisovans might be as far north as they had lived. It would have been way too cold for them to survive if they had gone further north. From there, they traveled as far south as Indonesia. This was possible because, during their time, sea levels were lower than today. So Indonesia was connected to mainland Asia. But they probably didn't make it to Australia since it was still separated by water. These three groups mixed together too. Scientists have found a bone of a girl who had a Neanderthal mom and a Denisovan dad. It's the only first-generation hybrid human we've discovered. She even got a cool nickname, Denny. One of the mysteries about Denisovans is how they disappeared. Maybe they mixed so much with other humans that they just blended in. Or it's possible that modern humans' ancestors were stronger, had better tools, or even brought some diseases that didn't affect them, but affect Denisovans. Climate and where they lived might have also played a role. Denisovans lived in a wide range of environments, from cold parts of Asia to tropical Indonesia. Climate changes and the challenges of different habitats might have been really difficult to survive. But it's hard to draw strict lines in our family tree. We're still relatively new at learning about it anyway. Who knows how many new members we are about to discover? Half a century ago, a team of scientists had an idea that a collection of fossils they found at the Great Rift Valley in Tanzania were actually the remains of some new human species. Yup, that was the time when we welcomed Homo habilis into the family. It was a big discovery at that time since people mostly believed that the story of our evolution had been really simple. First, there were Australopiths that looked like apes. After them, there was Homo erectus, the upright man. They most likely lived in Africa around 2 million years ago, but also expanded really quickly across Eurasia. It was the first human species that we know about to have traveled such long distances to find a better place for life. They looked and behaved like humans. Plus, they were probably the first of our ancient ancestors who learned how to deal with fire. Maybe they were the first to cook food as well, and that's what we're definitely thankful for. Cooking food was an innovation that made the human diet more nutritive, and we could grow bigger and smarter brains. So, yeah, Homo habilis made things more complicated. They could walk on 2 legs, but they could also be better at climbing trees than walking on the ground like us. Plus, their brains were smaller than what a human should probably have. At first, it seemed these fossils could be from a completely different side of the family, related to other creatures, Australopithecus africanus, that looked like apes. But more and more digging showed that even though its jaws and teeth were similar, Homo habilis was still bigger and a bit different. The name means handy man, because they were probably able to make and use simple tools. Searching for more fossils in Africa wasn't easy because a team of researchers had to deal with wild animals and tough conditions all the time. But eventually, they managed to find some teeth and a strange skull that was, again, something different from the ancestors we knew about. The teeth were really big, so this new fella got the nickname of Nutcracker Man. For a long time, everyone believed this kind had evolved to eat hard foods. But the fossil teeth didn't show much damage, so they might have been eating food that was softer than we thought. This finding might help us understand how our teeth have been evolving through time, too. And right there, in the same layers of soil where Nutcracker Man was lying, they found ancient stone tools. At first they thought those had belonged to Nutcracker, but as they kept digging, they found more fossils that didn't match Nutcracker Man. It means that someone else must be the real tool maker. But that's another story for another time.
Admit it, whenever you think about Neanderthals, you picture these large, human-like creatures wandering around, bumping their heads, afraid of fire, and making weird noises. That's really far from the truth. There's actually more Neanderthal DNA in your genome than you know. It's estimated that up to 4% of the DNA of some modern humans can be traced back to Neanderthals. If you have no idea who these people were, let me get you up to speed. The Neanderthal was a species of early humans that lived in Europe and Western Asia as early as 200,000 years ago. As for their appearance, they looked sort of like us, but they were physically stronger. Their skeleton was also more durable and able to cope with the harsh environment. I mean, 200,000 years ago, people didn't live in houses or apartment complexes. So, their bodies needed to be able to survive in the wild. What's even more surprising is that their brain was larger than ours. But did that make them smarter? To answer that question, let's look at how these people lived back then. Neanderthals were hunter-gatherers, meaning they had to hunt and search for food. Back in their prime years, farming wasn't a la mode yet. They were skilled at making tools and objects to protect themselves with, like spears and stone knives. They used these things to hunt animals, yes, but also to make clothing. And speaking of garments, a new study showed that Neanderthals might have been more fashionable than we'd previously suspected. These recent findings show that they may have been skilled in using plants to create yarn. This is based on the discovery of pieces of fabric from over 50,000 years ago in parts of Europe, where Neanderthals used to live. This is really important because it's rare for archaeologists to find perishable artifacts, such as plant products. Most of the things we find these days from previous eras are pottery and pieces of rocks and bones because they can better resist the test of time. Researchers used a special microscope to examine a cord fragment made of twisted fibers, which may have been used for a tool or net. Since it looks like they were able to twist plant fibers into making a cord, Neanderthals had probably been much smarter than we thought. It shows that they had great observational skills and were great at picking out which sort of plant was better to use. They also used fires to keep warm and cook food. It looks like Neanderthals were able to make use of flames that popped out spontaneously but were not able to create them consistently. Scientists have looked at some Neanderthal sites and found large amounts of ash. That means they had to constantly maintain a fire because they were unable to start it again if it went out. Other specialists believe Neanderthals did use fire, but they did not necessarily need it due to their physical abilities, which allowed them to handle cold temperatures better than modern humans. So, what did Neanderthals eat? Scientists have been able to get a glimpse into their menu, but that's only because these ancient creatures had this nasty habit. They didn't brush their teeth. If you don't brush your teeth regularly, a film called dental plaque will form on the surface of your pearly whites. Over time, this plaque will harden and turn into tartar or dental calculus, which is a combination of minerals, microbes, and leftover pieces of food. Scientists can use bits of the material trapped in dental calculus on fossils to study what our distant cousins ate and what their lifestyles were like. They can also examine ancient DNA to determine the species of microbes present in the mouth of a Neanderthal. Turns out that those living in Belgium ate mostly meat, including woolly rhinoceros and wild sheep, according to the DNA found in their teeth. On the other hand, the Neanderthals found in the El Cedron cave in Spain had a more plant-based diet, including mushrooms, pine nuts, moss, and tree bark. Other Neanderthals from different locations also showed consistent evidence of eating plants. One of the Spanish Neanderthals even had dental problems, and the researchers found evidence of medicinal plants in his teeth. He may have been trying to treat his pain. Another study performed at the University of York found that Neanderthals had some sort of prehistoric healthcare system. It worked regardless of how bad the injury or illness was. The research suggests that this care was provided out of real concern rather than self-interest. This challenges the stereotypical image of Neanderthals as brutes and selfish creatures compared to modern humans. The study found that many Neanderthals had severe injuries requiring ongoing care, such as massage, fever management, and hygiene. One individual who was around 25 to 40 years old at the time of his passing had a degenerative disease that likely severely limited his ability to contribute to the group. Despite this, he was carefully buried, which shows that he remained an important part of the group, despite not being able to contribute much to the daily workload. In case you're wondering, Neanderthals aren't technically our direct ancestors. They're sort of a distant relative, if you'd like, because some of them lived at the same time as modern humans. We coexisted for thousands of years, with Neanderthals living in Europe and Western Asia, and modern humans spreading out of Africa around 50,000 years ago. There is evidence that the two species interacted and even interbred. That's why some humans today have Neanderthal DNA in their genetic makeup. However, the precise nature of their relationship is still debated among scientists. Despite their physical advantages, Neanderthals eventually went extinct. Some people think Neanderthals as a species were not successful because they disappeared a long time ago, but they actually did very well. They lived in difficult conditions for a very long time, much longer than modern humans have been around. Modern humans have only been around for about 100,000 years or so, and only started living in cold areas about 40,000 years ago. There are many factors that may have led to the extinction of Neanderthals. It is believed that changes in their natural climate and competition with modern humans were two of the main reasons. Neanderthals specialized in hunting certain animals, but when those animals went extinct, they may have struggled to find food. Additionally, modern humans had advantages, such as trade networks and better technology, including sewing needles or bows and arrows, which may have given them a competitive edge. Although there is no evidence of direct conflict between the two species, it is known that they interacted. Some people even believe that Neanderthals did not fully go extinct, since their traces of their DNA can still be found in some people. So, what if the Neanderthals hadn't gone extinct? Charles Darwin pointed out that many of the unique traits of humans, like emotions, intelligence, language, and social behavior, can also be seen in some form in other animals. Our closest relatives, such as Homo erectus and Neanderthals, were also quite similar to us. However, Homo sapiens are the only surviving members of the hominin group, which includes around 20 known and potentially many more unknown species of humans and human-like apes. Even if the Neanderthals had survived, they would have probably integrated into society and evolved at the same time as modern humans did. One theory suggests that since they were outnumbered at one point by Homo sapiens, their traits would have eventually merged with ours. Those less advantageous, like their inability to produce fire, would have disappeared over generations. Other theories suggest that maybe they wouldn't have wanted anything to do with us. Looking at our differences rather than our similarities, maybe they would have developed their own communities, choosing to live separately from the modern world. Either way, it's hard to predict how a species that disappeared so many years ago would behave today. But what we do know is that you need to think twice next time you want to call someone acting weird a Neanderthal. Your DNA might make you the Neanderthal in the room.
Let's embark on a wild thought experiment. What if we could magically travel to all our ancestors in chronological order? Could we talk to them and actually form some connection? And just how far back can we go while still connecting with them? Well, let's see. Primates were the funky cousins of other mammals. Around 85 million years ago, during the late Cretaceous period, they went their own way and became the first of their kind. Human evolution is very complicated, and we can't draw a distinctive line on where it started. But we're going to start with hominins. Hominins are a group of primates that include all the species leading up to Homo sapiens. So, imagine you hopped in your super cool time machine and landed in the past, way back when hominins were chilling around. What would happen? First off, you'd spot these quirky creatures roaming around with their short, hairy bodies, curious faces, and big eyes. They might look a bit different from you, but that's part of the fun. They were excellent climbers and incredibly curious about the outer world. They munched on fruits, nuts, and whatever they found in nature. And yes, surprisingly, humans aren't meat eaters by nature. Originally, we all were vegans. Of course, with them, you can forget about proper communication. But still, primates are incredibly smart. So, a good old game of charades could do the trick. Mime your way into their hearts with friendly gestures, and they'll be thrilled to see a futuristic traveler like you. These hominins were curious beings, so they'd probably be very interested in you if you were friendly with them and gave them some food. Next, let's move on to Homo habilis and Homo erectus. Their period, the Stone Age, started about 2.6 million years ago. As you can guess, it was the time when we started using stone tools. The Stone Age lasted for roughly 3.4 million years and ended between 4000 BCE and 2000 BCE. It ended with the beginning of metalworking. Homo habilis, or handyman, was like the MacGyvers of the Stone Age. These crafty creatures were the first to use stone tools. And Homo erectus was the upright man. They were a bit more recent. As their name suggests, They were the first to walk on two legs like us. They might have looked a bit different from modern humans, but still. So what were their lives like? Well, they still were true survivors. Homo erectus loved to explore and tinker with things. They made simple stone tools, like sharp rocks for cutting and scraping. They were basically the early inventors. Homo erectus was quite adventurous. They left Africa and traveled to far-off lands, exploring new territories. They were the first ones to set foot in places like Asia and Europe. They lived in caves or simple shelters made of sticks and animal hides. And let's not forget their wild fashion sense. Animal skins and leaves were their trendy outfits. But don't think they just sat around all day. They were hunters and gatherers, seeking out delicious fruits, nuts, and even hunting animals. How would you communicate with them? Well, they used simple grunts, gestures, and body language to understand each other. So, if you met Homo habilis and Homo erectus, you'd be in for a wild ride. You could show them some advanced technology to impress them and teach them some new cool tricks. Next on our list are Homo heidelbergensis and Neanderthals. Homo heidelbergensis was like the cool older cousin of Neanderthals and us. They lived around 800,000 to 200,000 years ago. Picture them as sturdy and strong, with big brains compared to their earlier relatives. They were expert tool makers and loved exploring new places. The Neanderthals lived in Europe and Asia from 400,000 to 40,000 years ago. Neanderthals were super smart, and they had awesome adaptations to cold weather. With their thick, strong bodies and big noses, they could handle chilly winters like champs. Both Homo heidelbergensis and Neanderthals were skilled hunters and gatherers. They'd chase after mammoths and other big game with sharp spears they crafted themselves. But it wasn't all rough and tough. They knew how to have fun too. Neanderthals made art and showed their emotions and connections with each other. With these folks, you could draw pictures in the dirt, dance around, and make gestures. They'd get the idea. And finally, we meet Homo sapiens. Picture this. You're waking up in a cave with your family, trying to keep warm by a flickering fire. The cave is pretty cozy, isn't it? But nope, no permanent homes here. You're part of a nomadic tribe, moving wherever the food is best. Hey, but at least you've got some nifty tools to survive. Grab your awesome handmade spear, crafted by watching others or maybe invented by your genius self. Time to go hunting mammoths. And if mammoths aren't cooperating, just gather nuts, berries, and bird eggs. Stone Age humans were real foodies. They made flour from oats and spiced things up with wild onions and mustard seeds. There were artists too. Using minerals and bones, they created stunning images and even flutes for some musical entertainment around the campfire. You still can only talk in body language and facial expressions. But Homo sapiens were smarter than their ancestors. So you could even teach them basic gestures and their meaning, like hands up for mammoth and stuff. Maybe try doing a funky dance or a happy jig. That would get their attention for sure. But this wouldn't be the only way to communicate. Stone Age peeps loved drawing and making flutes, so you could totally join in on the creative fun. Show off your artistic skills with a drawing or two, or maybe even play some tunes. Don't worry, they would be impressed by your skills, even if you aren't that far away from them. But tools are definitely the way to their hearts. If you brought some handy gadgets or cool inventions from our time, they'd be super impressed. Just create some simple tool from the future that can make their lives easier, and they'll love you instantly. So, while you might not be having deep philosophical debates with the Stone Age crew, you can still share some good times. Learning is the way to go. Besides, even though life was shorter back then, averaging around 30 years, it's still enough time to find a partner and have kids. Though, the dating pool might be a bit limited. So let's leave that topic for another time. Just hold on to that axe at night because, well, sometimes our ancestors would eat each other and like to do some head-dumping battles. Yikes. Let's finish our journey with the Bronze Age, just for fun. This cool era lasted from around 3300 to around 1200 BCE, and guess what? They were all about that strong metal called bronze. It's the time when people got creative and started using bronze to make all sorts of cool things. Bronze is a combo of copper and tin, making it harder and more durable than anything else at the time. Awesome civilizations started popping up all over the place. They either made their own bronze by smelting copper and mixing it with tin, or traded for it with other places. So, as you step into this ancient era, you'll be amazed by the sight of bustling Bronze Age cities with majestic bronze gates, amazing markets, and grand temples dedicated to powerful gods. During the Bronze Age, we finally developed languages and writing. Mesopotamia and Egypt were leading the way with their fancy cuneiform and hieroglyphs, the earliest writing systems ever. They were basically the kings of calligraphy. Remember, the language might be a bit different. You'd be hearing unfamiliar words. But with these humans, you can at least use drawings, art, and many other things to communicate. Anyway, this is what meeting our ancestors would be like. What a wild journey through time. So, remember to cherish our past and appreciate the wonders of our modern world. Stay tuned.
54,000 years ago, there was one interesting group that lived in caves. A father, daughter, and a couple of other members who were their close relatives. And the cool thing here is that they were the first Neanderthal family we know about. A team of scientists studied ancient DNA from their teeth and bones to learn more about early human society. And this research showed a cool thing. They probably lived in these caves at the same time, together. There were 11 Neanderthals that lived together in one cave, and 2 others from another cave that was somewhere close in the neighborhood. So there were 13 of them, 8 grown-ups and 5 kids. Together with their DNA, scientists also found their stone tools and animal bones. Neanderthals are the ancient human relatives that are definitely the closest ones to us. Their skull was long and flattened if you compare it to the skull of Homo sapiens that's more globular. They also had this specific prominent brow ridge above the eyes. You can easily recognize them by their face too, with the central part of the face protruding forward. Plus, they had a large, broad nose. Some believe their nose was a way of adapting to living in cold, dry environments. When the inside of the nose is bigger, it moistens and warms the air you breathe better. Unlike us, they didn't have much of a chin. Also, scratch marks on their front teeth tell us Neanderthals used them like a third hand when they would prepare food and work with materials they used. Their bodies were strong and muscular, with wide shoulders and hips. Their average height was 5 to 5.7 feet, with a weight of 140 to 180 pounds. Their stocky appearance with short lower arm and lower leg bones minimized their skin surface, better protecting them from the cold. Their lifespan was about 30 years, even though some of them lived longer than that. Neanderthals would dwell in regions that are now Europe and Asia for over 350,000 years. They disappeared somewhere around 40,000 years ago. That's about the time we could find traces of Homo sapiens in Europe. Their families were close-knit groups of 10 to 20. That's a lot less than the population of any ancient or modern human community. It's more like the size of groups of endangered species that are close to going extinct. These Neanderthals lived in their caves with small communities, but they didn't live isolated from the rest of their kind. They relied on each other for survival. They took care of one another, especially those who couldn't care for themselves. Also, their caves aren't as primitive as we might imagine. For example, they had a hole close to hearths and they would probably use it to heat water. Also, they would organize their space. They had sleeping areas, parts of the cave where they could leave trash, and areas where they could make stone tools and prepare their food. They would travel through the river valleys to catch their prey, such as bison, ibex, horses, and other animals. They were skilled in planning their strategies. Some studies showed they were aware of reindeer migration patterns, so they would plan their actions according to their predictions of where their prey could move. One of the biggest animals they would go after was the woolly mammoth. You know them, a relative of modern elephants covered in fur with a weight of up to 12,000 pounds that went extinct a long time ago. And studies showed woolly mammoths and Neanderthals shared some genetic traits. It's not that surprising when you think about it. Both species developed from African ancestors before they managed to adapt to the cold, harsh climates of Eurasia during the Ice Age. So they faced similar conditions and both went extinct at about the same time. Neanderthals also used stone to make tools, similar to ones other early humans used, such as scrapers and blades made from stone flakes. These tools scientists found in both of the caves they studied are created using the same raw materials. That means the communities probably hung out and interacted with each other in some way. Until the 20th century, many thought that Neanderthals were very different from modern humans, considering their genetics, physical appearance, and behavior. But more recent discoveries about this well-preserved Eurasian fossil population have shown that some of the people in it were the same as people alive today. Neanderthals lived before and during the last Ice Age, in some of the harshest places that humans have ever lived. Besides their tools and catching animals, they also gathered plants from around their area. They would also eat cooked vegetables relatively often. Their ability to stay alive for tens of thousands of years during the last Ice Age is a good example of how humans can adapt to almost any situation. Neanderthals made the earliest cave art that we know about. Scientists explored 3 Spanish caves where they lived, and all of them had black and red paintings of dots, animals, and geometric symbols, together with handprints, hand stencils, and engravings. These paintings were made more than 60,000 years ago. Since Homo sapiens came to Europe 20,000 years after that, we can assume Neanderthals were the only human species on the continent at the time, so they must have been the ones who created this art. Also, these caves were 435 miles apart, so it wasn't like only some of the Neanderthals knew about it. Paintings were obviously their long-lived tradition. They were also big fans of fashion. They made their own jewelry, some of it out of eagle talons. The oldest examples we could find are nearly 130,000 years old. They also most likely used pigment to camouflage or decorate their bodies. Also, Homo sapiens weren't the only species that used fires. Researchers looked at more than 140 fireplace sites across Europe and realized Neanderthals used fire there for a long time too. These signs included charcoal, burned bones, and heated stone artifacts. Neanderthals used fire for cooking food and making tools. They would stick wooden shafts into pieces of stone with pitch, which would be like natural glue. Since burning the bark of birch trees is the only way to make this sticky liquid, the Neanderthals must have been able to control fire. Most people imagine Neanderthals probably grunted, but that's not true in reality. They didn't quite sound like us either. Their big chest, posture, and the shape of their throats probably resulted in a voice that was louder and higher pitched than the average human's voice. They probably didn't have sophisticated vocabularies as we do, but they could use complex speech because they had the hyoid bone. It's this little thing we have in our neck too, the one that supports the root of our tongue. It's the same feature that allows us to vocalize as we do. They were more similar to us than we might expect. Some believe Neanderthals even built boats so they could sail across the Mediterranean. And it's not like Neanderthals lived somewhere, went extinct, and then modern humans showed up. It seems these groups did meet around 100,000 years ago in the Arabian Peninsula or in the Middle East. That's when the first groups of modern humans were moving from Africa. Scientists analyzed the DNA of one of the Neanderthal women that lived more than 50,000 years ago, and it includes genetics from modern humans too. Some traits we have, like skin and hair color, mood, and sleeping patterns, are connected to the amount of sunlight we get. Neanderthals lived in Europe and Asia for a long time before modern humans arrived there, so they were used to less sunlight compared to the ones who came from Africa. Neanderthals had different traits because of their exposure to less sunlight, and these traits were passed on to their offspring when they had children with modern humans. In other words, some of the traits that modern humans have today are influenced by Neanderthal genes. For example, people who are night owls often have Neanderthal genes. Also, around 1% of Neanderthals had light skin, red hair, and perhaps even freckles.
So, how would you feel if you accidentally met your relative who lived around 9,000 years ago? It's exactly what happened to Adrian Targett, a retired history teacher from Somerset, England. He noticed a familiar face on the front page of several newspapers. It was the image of the so-called Cheddar Man. Sounds cheesy, right? Anyway, his skeleton was discovered in 1903 in Cheddar Gorge near Somerset. Now that makes sense. Scientists used his DNA as a model to create a portrait of one of the oldest humans found in Britain who lived back in the Mesolithic period. Cheddar Man's initial DNA analysis has shown that he was a typical representative of the Western European hunter-gatherer society. Years later, with the use of new technology, the scientists managed to establish that he had dark brown or black hair, dark skin, and bright blue eyes. In 1997, researchers analyzed genetic material taken from the cavity of one of Cheddar Man's molar teeth and compared it to samples taken from locals whose families were known to have lived in the Cheddar area for centuries. The test found that Mr. Targett was, indeed, Cheddar Man's direct descendant. The genes were passed from mother to daughter across 300 generations. The only obvious difference in appearance between the two was skin coloring. As humans migrated north from the harsh African sun many thousands of years ago, their skin got lighter to absorb more sunlight and vitamin D. But this process didn't happen overnight. So the skin of Cheddar Man is much darker than that of his offspring, who was born under the cold British sun. Mr. Targett admitted that he didn't know how he felt about the test results. He wasn't surprised, though, as he recognized his nose shape and bright blue eyes in his ancestor's face. His name ended up in the Guinness World Record books as the farthest traced descendant by DNA. Studying Cheddar Man also opened up some new evidence of when and how farming came to the British Isles. Researchers concluded that the hero of the day was a part of an extended group of families of around 30 people. It looks like they came after the woolly mammoth had disappeared, but before farming became a thing in the area. The oldest traceable family tree before Mr. Targett's case stretched back 5,200 years, which is older than Rome. The lineage of the Chinese Kang clan spans over 80 generations. It includes more than 2 million people, and one of them is the famous philosopher Confucius himself. And it still holds the title of the most accurate longest family tree. Ever wondered how many ancestors you have? Well, let's do some math here. So first, it's 2 parents, 4 grandparents, 8 great-grandparents. Yeah, if we keep multiplying by 2 and go back 10 generations, we get 1,204 ancestors. It sounds like quite a crowd, but 10 generations aren't that many when it comes to thousands of years of human history. About 20 generations, or 400 years ago, each of us should have about 1 million ancestors, and 800 years ago, 1 trillion ancestors. In theory, it leaves us with hundreds of trillions of people, which is practically impossible since there have never been that many people on Earth. Imagine there lived a guy around 1,000 years ago. His daughter was your mother's 33rd great-grandmother, and his son was your father's 33rd great-grandfather. It would mean he's on 2 branches of your family tree, both on your mother's and on your father's side. Most people who lived at that time would actually appear on our family trees not just twice, but thousands of times. There were just around 200 million people on Earth back then. It means that each of them would have to appear 5,000 times on the family tree of each of us living today. Life isn't that mathematically even, though. Some people from the past never had children, and others had many of them, which means they'd be featured on the trees of many, many people. Steve Olson, author of the book Mapping Human History, used the help of a statistician, a computer scientist, and a supercomputer to calculate how interconnected the human family tree is. If you went back in time 2,000 to 5,000 years, you'd meet a human who could call everyone currently living their descendant. A journey a bit further in time, say 5,000 to 7,000 years ago, would let everyone living today meet their ancestors, and that would be the same people. This supports the theory that our family trees aren't inverted pyramids that keep endlessly widening, but diamonds. You start from yourself, and as you go back several generations, you see it grow wider. Then, at some point, the tree starts narrowing as it goes down to only a few ancestors and even to one person. This person probably lived a few thousand years ago, during the reign of Tutankhamun, or maybe during the golden age of ancient Greece. They didn't do anything particularly outstanding, and they never knew they would be the ancestor of nearly 8 billion people living on our planet today. So, the next time you visit an exhibition of ancient Egyptian art from the times when pyramids were built, remember that every hieroglyph and every piece of jewelry there was created by one of your great-great-great multiplied by hundreds grandparents. And that mummy in the center of the hall most likely is your ancestor as well. On average, most of us can trace our ancestry with high accuracy back to the 1600s. If you decide to build your family tree, you've got to do some research and learn as much about your ancestors as you can. Start at home and study all papers and photos you can find in the attic or basement. Letters, especially the ones with dates on them, diplomas, report cards, diaries, and postcards are all going to be your best friends in the search. You can also check out the local library or archives. They should have census records that can help you. The results of your search will depend on your ancestors' social status and past wealth. It's always easier to find data on someone wealthy and important to their community. Now, in some cases, birth records might be destroyed or misplaced. Your origins can also affect the search, as many cultures had oral histories and didn't record anything in writing. In Western Europe, they started keeping genealogical records during the 1500s. Before that, family members memorized their whole lineage, and of course, they mostly remembered only the names. Sometimes they'd also remember major events alongside key ancestors. In some cases, in ancient times, genealogy helped find the lawful heir to the throne. Royals and nobles who were candidates for the position would present their genealogical trees, just like you send your CV and recommendation letter now. The U.S. didn't start keeping lineage records until around 1910. Switzerland has records that stretch back over 700 years. China, for comparison, has been doing it for over 2,000 years. Another priceless source of knowledge is your elderly relatives. Each artifact you find and show them will most likely encourage a long and interesting story full of names and details. There are many free websites that will help you organize the information you find. The more users the website has, the more likely you are to find some of your ancestors in someone else's tree. You can also use your findings, especially stories you managed to recover, to write your family history book. Be prepared that this research might take many years. The more ancestors you find, the more you'll still have to discover. In case you prefer biology to paperwork, you can try taking a DNA ancestry test. Scientists will analyze your genetic material to trace the migration paths of your ancient ancestors from 1,000 years ago, and will give you some information on your ancestral roots. You won't learn much about who your relatives were, though. Current tests can't go back further than 8 generations. There are many testing services available, and if you choose the ones with a large database, you have more chances of getting a match with other people looking for ancestors. Happy hunting! With more than 8 billion people in the world today, it's hard to imagine there was a time when there were so few human beings that they almost went extinct. It happened about 900,000 years ago when our ancient ancestors faced a crisis. Recent studies tell us there were only about 1,280 of them left, which is an incredibly small number. It's like just one village or a very, very small town left alone on the whole planet. The human race got into a population bottleneck where almost 98% of people disappeared, and things were tough for them for more than 100,000 years. We don't completely understand why this happened, but it was likely the result of tremendous changes in Earth's climate. It was a time when periods of cold weather lasted longer, the sea was colder, and there were more glaciers. Monsoons were immensely powerful, and yet there was less rain. These changes had an impact on wildlife species in Africa and Eurasia, and many plants and animals that were food sources for people disappeared. But at some point, our ancestors showed their strength and managed to bounce back despite tough times. The numbers started to go up again because people learned how to handle fire better. Plus, temperatures got warmer too. But what would the world look like if nature had defeated us and it all had really stopped for humanity back then? Let's take a trip to some parallel dimension where it really happened. In that universe, there wouldn't be empires, pyramids, and impressive achievements that some old civilizations left us. No neighborhoods, cities, your favorite park, or that bench where you like to sit and drink your coffee. No coffee. Ouch, that hurts. No pools, adventure parks, and no rush at the beaches. No creature would be able to go to another continent separated by the ocean. There would be no ships or planes that could carry it. Animals would have to wait for tectonic plates to move again to visit new territories. Wow, you've just realized how incredibly silent the world is. All because nature almost never produces as much noise as humans do. Our buildings are noisy, together with cars, motorcycles, and all other vehicles. If you live somewhere by the airport, you know how much noises planes can make too. And here, no one's phone's ringing. You don't hear music coming from bars or gyms. Wow, look how incredibly blue the sky is. You've never seen a sky like that in your world. The rain and wind scrub the surface of our planet clean, although there's not much work to be done since there's no dust and smog humans produce. I mean, there is dust, but a different kind, one that nature creates. We don't really notice it since we have so many heaters and air conditioning systems that blow air and all that dust around. The only drinking water you see is in lakes and rivers, and lots of different animals get together in these areas. It takes a while to get used to it. Wherever you go, there are wild animals passing by. There are no dogs, cats, or other pets you're used to. There's no electricity either. In case you've brought your phone, take pictures as fast as possible because you won't be able to charge your gadget when it runs out of battery. There's no internet though, so you'll be the only one who will see the photos. It's so weird to see grass so tall and wild. No one mows it, so it's hard to walk, especially considering there are no roads. And you don't have a scythe or any other tool that could help you clear your way, because human civilization hasn't reached that level of progress. Wow, there are plants you've never seen before. Every time a tree drops a seed, something new might grow. And there are no humans to select which plants they like and which they don't. You suddenly feel nostalgic, thinking of carrots, broccoli, potatoes, and all other vegetables people once started growing on their farms. You can hear tons of bugs buzzing around. We usually do everything to get rid of them, and now, without humans, you get to see how annoying they really are. Hey, the sun is going down. Without electric lights, all creatures just follow the rhythm of nature. So, if you're up for a late-night walk, wait for the moon and stars to lighten your path. But be aware of night predators. You may face creatures that didn't survive in the world where humans rule. Fire. Luckily, there's a river nearby, so you jump into the water to get to the other side. Fires happen more frequently in the world without humans. For instance, lightning can strike a tree or set a brush on fire. No one is there to put the flames out, so fires just keep spreading until at some point they burn themselves out. It's hard to see the world like this, but it's even harder to accept that Earth is fine without us. just like it's doing well without dinosaurs, megalodons, woolly mammoths, dodos, and other ancient creatures that went extinct. Back to the research. Some scientists don't think our ancient ancestors were really that close to extinction. To get these results, researchers used FitCool, a special tool that helps study changes in ancient human populations by looking at the genetic information of modern people. They examined DNA from over 3,000 individuals in Africa and other places for this study. Some believe that the actual population numbers might have been bigger. The method used focuses on a small group of breeding individuals and may not exactly represent the whole population. There may be many archaeological sites in Eurasia and Africa that date back to the time when this population decline might have happened, so it may have affected just some groups of people in certain areas. Either way, not only wasn't it the end, but it was a new beginning. Two ancestral chromosomes combined to create a structure known as chromosome 2 in modern humans. This might have been the start of a new species, because there was a split between our ancestors and other ancient humans, such as Neanderthals and Denisovans, our ancient cousins. Some evidence tells us this idea is plausible because our common ancestor lived about 500,000 to 700,000 years ago. Well, humans did survive all those devastating moments in history, but scientists believe that the extinction of our species is a matter of when, not if. Our fields will overgrow, cities will end up in ruins, and bridges will fail. Nature quickly reclaims the landscape where humans don't go. Check out how these roots and trees have taken over the temple in Cambodia. Roman ruins still defy time for over 1,500 years now. Some of the buildings and things we create in the modern world will do it too. Nature will break everything down at some point, and if humans were to go extinct, who would replace us? It took 200 million years for our kind to evolve from the first mammals. Who can repeat this entire process again? The last common ancestor of chimps and humans lived 8 million years ago. Knowing this, it seems possible that if Homo sapiens went extinct, a new species capable of using technologies would evolve from chimps. But hold on. There's something called the Fermi paradox. Even though there are hundreds of millions of rocky planets that could host life in our galaxy, we don't see any evidence of its existence. Our galaxy is 13.5 billion years old, so you can't say life hasn't had time to develop. One possible explanation is that certain crucial steps in the evolution of intelligent life are so rare they hardly ever happen. So, Earth would get along fine without us. The only ones who would care are us. And right now, we need to care a lot. You know what? Every species on the planet needs to adapt to the world around it to survive. Human beings are no exception. We didn't exist millions of years ago. The oldest skeleton of a modern person ever found is about 196,000 years old. But even in this relatively short period of time, our species has evolved a lot. In fact, we've never stopped evolving. At least that's what some scientists think. And some of our traits seem to prove it. About 20,000 years ago, I wasn't around then, only children could drink milk without getting an upset stomach. But then humans domesticated animals like cows and goats. A new gene developed in people's bodies down the generations. Today, about a third of all the world's population can drink milk in adulthood. In fact, this ability actually developed independently among different groups of people all over the planet. Our jaws are also not as big as the ones our extinct relatives had. They got smaller because our soft processed food is nothing like the diet of our ancestors. Our teeth themselves have become smaller too, and some have even disappeared completely. Plenty of people may never develop third molars, known as wisdom teeth. But for our ancestors, these teeth were vital. Third molars usually develop when someone is 18 to 25 years old. By this time, most of our ancestors' teeth had become worn out, so the third molars were possibly replacements. But some slight changes in human anatomy may have nothing to do with evolution. For example, people have generally gotten taller over the past few hundred years. The most likely cause of this is simply better nutrition, as well as access to modern medical care, and perhaps basketball. But what changes await humanity in the future? Of course, nobody can tell for sure, but the experts do have some interesting theories. One possibility is that we could get shorter as we adapt to life on our overpopulated planet. Studies have shown that shorter people consume a lot less energy and resources than taller people. In the era of hunter-gatherers, humans didn't meet many others in their day-to-day lives. Now, people have to adapt to life in densely populated cities. And who knows, maybe given enough time, our genes will respond to this change and reduce the average person's height. Another possibility is that more and more people will look alike. Modern humans travel a lot. As different types of people interact and have children, our genes are becoming more and more mixed up. In the future, this might make some physical characteristics a lot more unusual. The average-looking person might have darker skin and hair, and traits like freckles or blue eyes could become a rarity. Some scientists think that evolution won't play an important role in our future at all. Unlike our ancestors who lived millions of years ago, we now have a very advanced culture based on cooperation and modern technology. So, we no longer need to literally struggle to survive. Because of this, we may actually stop developing as a species and remain pretty much the same far into the future. If our evolution does continue, though, there's a chance we'll become more complex and intelligent creatures. Because of technological progress, the way we deal with problems could depend more on our intelligence than our physical abilities. So our brains might become larger. This may already be happening. I know mine is getting bigger. Some scientists' measurements show that the skulls of Americans are actually getting bigger on average. The room in there for the brain has increased about the size of a tennis ball. Or maybe the opposite will happen, and our brains will shrink. This direction of development has actually been around for a lot longer. Some people think that the male human brain has been getting smaller for the past 20,000 years. Hey, just ask females. If it continues to decrease at the same rate for the next 20,000, it'll end up being the same size as the brain of an archaic human who lived about 2 million years ago. Wait, does that mean we're becoming less intelligent? Well, a bigger brain doesn't always mean greater intellect. We just might be evolving to have smaller but super efficient brains. Another theory is that our bodies might learn to use calories from fast food. Things like pizza, fries, and donuts contain trans fats. These chemicals are difficult for our bodies to digest. But what if humans of the future somehow adapt to this kind of food, if we eat it for long enough? After all, the same process has already happened with milk. In a few thousand years, people may develop genes that can break down trans fats and absorb something healthy from them. If they still enjoy eating burgers and fries, of course. Donuts. People of the future might have less hair than we do today. Hair was vital for our ancestors. It helped regulate their body temperature, keeping them warm in cold climates and cool in hot environments. Even today, we still have practically the same amount of hair as many apes do. But some scientists have pointed out that our hair is nowhere as near as important to our survival as it once was. Since we now have modern heating systems and clothing for any environment, maybe given enough time, we'll become a lot less hairy. Then they'll be saying, he wasn't very fuzzy, was he? Yet our hair still serves many purposes. Our eyelashes protect our eyes from dust, and eyebrows keep them clear of sweat. Some experts think the hair on our heads even helps stabilize the temperature of the brain. So we probably won't become completely hairless, just a little smoother. And now the bad news. Human beings of the future may have weakened immune systems and become more vulnerable to illnesses. New medical technology and antibiotics can improve our health, but there's the risk that they could make our immune system lazier and unprepared for fighting infections over time. Many generations down the line, it's possible that the human body might not be able to withstand even simple diseases without serious medical help. Today, human development isn't determined by biology alone. Technology also plays a role. Maybe one day, people will stop waiting for evolution to give them what they want and begin to change themselves using advanced tech. Doctors already use artificial devices to help people with health problems. So who's to say that machinery and computers won't be used in the far future to completely change our physical abilities? Our descendants might get different kinds of brain implants. Or it could be that people will be equipped with artificial eyes with camera functions. But in this scenario, we could also end up being less knowledgeable. Why learn a foreign language or remember historical dates when all the world's information has been downloaded right into your brain? If human beings eventually become a multi-planet species and colonize Mars, our bodies could begin to adapt to life beyond Earth in interesting ways. The contrast between the environment on Earth and the red planet is so huge that evolution may actually speed up. In this case, humans could adapt to the new physical conditions in as little as 6,000 years, or just a few hundred generations. In the low-gravity environment of outer space or alien worlds, the structure of our muscles could change. We won't need some of them, while others will develop more quickly. The amount of body fat we have may increase in a cold climate. Low temperatures may also make us grow thick, long hair again. Our skin may become more pigmented and therefore better protected from harmful UV radiation. And our eyelids might get thicker to protect our eyes from all the cosmic rays outside the Earth's atmosphere.
Phantasmagory is said to be the first animated film ever. It was made in 1908, and it's one of the earliest examples of hand-drawn animation. But did you know that ancient people entertained children with cartoons about 2.6 million years ago? A new study reveals that ancient people were the ones who first made pictures look animated. How? They carved pictures of animals on stones and placed them around fires. When the light starts bouncing around, those ancient animals just can't help but shake it and shimmy. The prehistoric carvings come to life in the flickering firelight, with those animals jumping in and out of focus like they're ready to party. Imagine how fun it would have been for prehistoric families to sit around a fire and create these animated carvings. It turns out that even some of the ancient wall paintings and carvings found in caves were inspired by their appearance in the moving light and shadows of flames. So, basically, these old-timey carvings were made to come to life when firelight hit them. And now researchers made a movie showing that cool effect on a 3D model of some horse engravings. The study says our brains are wired to see moving things in changing light, which is why these carvings probably mattered to our ancestors. In other words, cave people were like, hey, let's carve some cool stuff on this rock, and when we light a fire, it'll look like it's moving. And now these scientists were like, that's awesome! Let's make a movie to show this, everyone! Andy Needham and his teammates used modern scanning and virtual reality tech to study 50 flat carved rocks called plaquettes made of limestone. These rocks were found in southern France back in the 1800s and now sit in a museum in London. They are covered in 77 realistic carvings of all sorts of animals, like horses, reindeer, and chamois. Apparently, Homo sapiens, with a lot of time on their hands, made these engravings a whopping 12,000 to 16,000 years ago. Needham realized that many of these carved rocks were harmed by fire, some covered in white ash, others dried or fractured because of heat. Upon closer examination, he discovered pink bands of discoloration resulting from iron deposits in the stone. What's more interesting is that the animal engravings were often superimposed on top of each other, sometimes even melded together, or fitted around each other like some kind of prehistoric animal jigsaw puzzle. Rather than tossing out the old and starting anew, the ancient artists took animal body parts to create new hybrids. For instance, one of the rocks depicts both a horse and a wild cattle-like creature known as a bovid. In this masterpiece of prehistoric art, the horse's abdomen and neck become the back and neck of the bovid, while the horse's head forms the bovid's ear. What a creative way of recycling. Researchers believe that the prehistoric rocks from Prehistoric were used as primetime entertainment for our ancestors. More than one person carved the animals. People from different levels of skills showed their artistic glory, and it was a group effort. The fact that these rocks were found together also suggests that this was a community activity. So it's like families were all gathered around the TV, carving rocks and cheering on their favorite carved animals. Who needs Netflix when you have Paleolithic TV? The engravings on these rocks and the signs they were exposed to heat suggest they were created to look like they were moving. Sometimes you see different animals in different poses, so one would come to life, and then another, and then a different one. It's like a Stone Age version of Disney. Similar techniques might have influenced some of the ancient cave paintings, such as those at the breathtaking Chauvet Cave in southeastern France. The animal portraits there are also overlaid on each other, and some look like they were heated by fires underneath them, which means that our prehistoric ancestors might have been the first animators in the world. Alright, since we talked about young people's favorite pastime activity, shall we take a trip back in time to discover the world's oldest toys? One of the most ancient toys discovered was a simple ball made from clay and found in the ruins of ancient Mesopotamia. It might seem like a simple toy, but our ancestors were playing with them as far back as 3000 BC. But back then, they didn't have fancy video games or elaborate board games, so a ball was the pinnacle of entertainment. But the Mesopotamians weren't the only ones having fun. In ancient Greece, children played with dolls made of clay. In Egypt, kids had toys shaped like animals, but they also had dolls made from materials like clay, papyrus, and ivory. But the most impressive thing about these dolls? They had movable limbs. That's right, our ancient ancestors were playing with articulated dolls before it was cool. But it's not all fun and games. Toys also had a practical purpose back in the day. In fact, many of the toys discovered by archaeologists were actually used to teach children important skills. For example, Egyptian children played with dolls that were shaped like doctors, which helped them learn about medicine and healthcare. And let's not forget about the toys that were used to train future warriors. In ancient China, kids played with toy horses and chariots, which helped them prepare for a life of battle. Talk about getting a head start on your career. Moving on to primitive board games, which have been around for over 5,000 years. The oldest board game is called Senet, and was discovered in ancient Egyptian tombs. It's a bit like a cross between chess and backgammon, and it was so popular that it was played for over 2,000 years. Now that's a game with staying power. But let's not forget about toys for the little ones. Archaeologists have found ancient rattles and whistles that were used to entertain even younger members of their families. And if you thought your kid's toy collection was impressive, just wait until you hear about the ancient Egyptian princess who had over 100 wooden toys in her chamber. But perhaps the most surprising toy of all was the yo-yo. That's right. The yo-yo has been around for over 2,000 years. It was first invented in ancient Greece and was often used in battle, believe it or not. But eventually people realized that it was much more fun to just play with it and do tricks. Marbles are also around as a toy that has been entertaining kids, and some adults, for thousands of years. Archaeologists have found evidence of marble dating back to around 5,000 years ago in the Indus Valley civilization. Back in those days, marbles were made from all sorts of things. Want to take a wild guess? Okay, I'll tell you. Fruit pits and small pieces of smoothed stone. That's right, those ancient kids were getting creative with their playthings. Some artisans even went the extra mile and crafted marbles from clay. Let's head back to ancient Egyptians and their adorable miniature boats made from ivory, wood, and clay. These miniatures may be acknowledged as toys, but they were also meant to represent crossing over to the other side. Viking kids had similar types of items too. A wooden toy boat over 1,000 years old was found on a farmstead near the coast of Norway. This toy looked like a real boat, and it would have been the ultimate cool thing, just like how kids today go nuts over race cars and drones. You can imagine little ones back then showing off their toy boats to their friends. Many of these toys are still pretty fun to play with today. There are many others left aside, like toy soldiers and spinning tops. Do you want to know more about ancient toys or gadgets from the early days of cinema?
There's an amazing place in Ethiopia, East Africa, called Hadar. This place is a treasure trove. We found tons of old animal fossils there. And among those remnants, we discovered something very special: the fossils of a creature called Australopithecus afarensis. One of these guys was found almost complete. You might know it today by the name Lucy, after a famous song by the Beatles. Lucy was a small lady, only about as tall as a kitchen counter. She lived 3.2 million years ago and became a huge celebrity when we found her in 1974. She helped us learn more about our early ancestors, creatures called Australopithecines. Around 10 to 12 million years ago, there was a group of animals that broke into two branches. One of the branches led to modern apes, while the other led to humans. This separation happened because one group decided to stay in trees and became what we now call gorillas, chimpanzees, and orangutans. They moved around using all four limbs and lived in forests. But the other group decided to live on the ground and try walking on two legs. Because of that, their brains started getting bigger over time. And over millions of years, they became bald monkeys who watch videos on YouTube. Yeah, you know who you are. Lucy, like other Australopiths, was a bit different from us. She still looked like an ape and lived during a transitional stage. She could walk on two legs, but didn't do it all the time. Sometimes she climbed trees, just like a monkey. She and her buddies were the first step in human evolution. Then came a new branch of evolution, Homo habilis, or handyman. They were the first members of the Homo genus because they were the ones to start developing stone tools and first show human creativity. They probably used these tools for scavenging and processing food. We found the first clues about them back in the 1960s. They walked around East Africa about 3 million years ago. They were pretty small, about 4 feet 7 inches tall. They didn't climb trees anymore and mostly walked on the ground. Their skull shape already resembled ours, unlike the more pear-shaped heads of Australopiths. That's because they had larger brains. After them, we had Homo erectus, the upright man. They lived about 2 million to 70,000 years ago. The name hints that this was the first hominin species that walked on two legs almost all the time. They were also the first to migrate out of Africa, spreading to Asia and Europe. And here, we had the real breakthrough. Representatives of Homo erectus had even larger brains and learned to make more creative and advanced tools. They created the first choppers, cleavers, and hammers, and used flakes as scrapers and knives. They probably used a lot of things, wood, bark, and even grass to make the first strings and ropes. With all that, they learned how to hunt large animals and probably hunted together a lot. They were also the first ones to start using fire, which changed our history forever. Over time, more Homo species emerged, including the famous Neanderthals. They're known for their European roots. They split from our common ancestor around 400,000 years ago. Now, even though we share one common ancestor, we didn't evolve from Neanderthals. They were a separate branch. All Neanderthals went extinct, but our evolutionary branch coexisted with them a long time ago. Neanderthals were resourceful, hunting both land and sea creatures. They left behind thousands of stone tools and even decorated caves with paintings. They had their own ceremonies, too. They started to bury those who passed away. They probably noticed that leaving them in the wild leads to spreading diseases and attracting scavengers. But they also showed care and love in their burial rituals. Then it was time for archaic Homo sapiens. They lived around 500,000 to 200,000 years ago, emerging in Africa and Europe. This was the last leg between our ancestors and our modern species, Homo sapiens. The brain just kept getting bigger. They started to show more complex behaviors, not only burial and interesting stone tools, but also smart hunting strategies and planning for the future. They probably had a diverse diet that included both hunting and gathering. And finally, we reached the anatomically modern Homo sapiens. They emerged around 200,000 years ago in Africa. They had a similar skeletal structure and brain size to modern humans, and their behavior was pretty close to ours. They had complex social structures, started thinking in symbols, and so on. They migrated out of Africa around 60,000 years ago, spreading across the globe and eventually replacing other hominin species, such as Neanderthals. They started to create their first languages and form their first words. The first words were probably very simple, like "ah" to call someone and "ma" for babies. After evolving into our final stage, we started advancing in our cultural and technological development. This development became very rapid over the last 200,000 years. About 12,000 years ago, the Neolithic period, also known as the New Stone Age, began. It marked the end of the glacial period. Humans started living in settled villages instead of constantly moving around. This change was brought about by the advent of agriculture, which allowed people to grow crops and raise animals like goats and sheep. Early humans started to domesticate animals, such as sheepdogs for herding. We also started making the first art, leaving famous drawings in caves, handprints, animals, mostly cows, hunting, and many others. We even created the first currency. We began using clay tokens for transactions. This marked the beginning of commerce and the use of money. And finally, we started writing. And now the events could be recorded and passed down through written records. This is when history officially began. From that point on, we saw the development of agriculture, the rise of complex societies, the invention of writing and the wheel, and the emergence of civilizations. Our tools became more and more sophisticated, languages appeared, leading to the diverse cultures and societies seen today. So, why have we stopped evolving? The truth is, we haven't. Human evolution is an ongoing process, although it's not as dramatic as it used to be. We adapt to different environments, have different skin tones, appearances, body sizes, and genetic mutations that have influenced traits like lactose intolerance or resistance to certain diseases. But the world we live in today is very different from the one our ancestors inhabited. We don't suffer as much because we've developed technology, culture, and social systems. Thanks to this, evolution slowed down, seeing that we're doing okay as we are now. What we started experiencing is cultural evolution rather than a physical one. Plus, 200,000 years is a pretty short time period, considering the time span of the universe or even of our Earth. We should see what happens to us in hundreds of thousands of years. I won't be around then, but there are some theories about that. There's a big idea that, in the future, humans and machines might merge into one super being. We call it technological singularity, a state where we humans lead our technologies to the point where we won't be able to control their development anymore. For example, if AI gets so advanced, it will change everything about how we live. Despite the current rise of AI, we shouldn't be too worried about it taking over the world, at least not in the next few decades. All we've developed now is weak artificial intelligence, little simulations. They might look scary to those who don't know much about AI, but the truth is, they have yet far to go before they reach the grand complexity of the human brain, not to mention consciousness. However, many people believe it's only a matter of time before AI reaches this level of intelligence, and then our world might change forever. There are other possibilities too. For example, one day we might reach a level where we merge with machines and learn to upload our consciousness in the cloud. In that case, we might become a hive mind, taking over the internet using our brains, becoming one giant consciousness. No matter what happens in the future, one thing's certain: technology is changing fast, and it's going to affect all of us sooner or later. Dinosaurs are some of the most fascinating creatures to have ever walked Earth. It's a shame that we won't be able to have Jurassic Park, where we can see some of the coolest creatures come to life. But we are actually living with some creatures that are just as old as dinosaurs, such as crocodiles and sharks. They haven't changed much since they appeared millions of years ago. But most dinos didn't make it when the asteroid struck Earth. In a way, the asteroid was a giant reset button for the planet. After hitting Earth, this space traveler wiped out almost every living thing. The sky was covered with ash, which blocked out sun rays. That meant that plants couldn't grow, and this made a lot of herbivores, really hungry. As a result, they had to change their diet and adapt to the new changes. This forced some of those dinosaurs to take on a new path in life, turning into some modern animals we know today. If the asteroid had changed its course just a bit, then dinosaurs would have remained the dominant species. So, what would have happened if dinosaurs had stuck around? Well, first of all, evolution would have played out differently for them. Maybe during those millions of years, humans would not have evolved to be on top of the food chain. Imagine a world where dinosaurs still existed today. If dinosaurs had evolved as humans did, then we'd have to compete with them. There were multiple species of humans, But Homo sapiens, also known as us, prevailed. A humanoid dino, or dinoid, would be something strange. First of all, they would look different, more reptilian than us. Our brain sizes would differ, and they would be physically bigger and stronger. Putting a human and a dinoid side by side would be interesting. First of all, dinoids would have scales as opposed to human skin, and their teeth would be sharper. They would probably not have 5 fingers on each hand, and their nails would be sharp claws. Also, we don't know what they would sound like, but they'd possibly be guttural like crocodiles. Dinosaurs had very good vision compared to mammals, so it's possible we'd see dinoids with large eyes. The population of Earth has reached a staggering 8 billion people, and we've changed our environment to suit our needs. With that said, if dinoids were the dominant creatures, then the environment would be suited for them. Speaking of physical features, scientists predicted what dinoids would look like if they had evolved into intelligent creatures that walked upright and had opposable thumbs. These wiggly thumbs are important for evolution, since they helped humans start using tools for defending themselves and hunting. The creature may not look like the ideal reptile, and its appearance might not be flattering. But if dinosaurs had evolved, then these creatures could be your classmate or colleague at work. Not all dinosaurs were alike, as their fossils have shown. Some were gigantic, while others resembled any modern-day animal. The biggest land-walking dinosaur was the Titanosaur, although the measurements are only rough estimates based on fossilized bones. It's estimated that the dino was around 122 feet long and lived between 100 to 95 million years ago. It was so massive that its weight was equivalent to 18 modern-day elephants. There were dinosaurs all over the world in different time eras, climates, and landscapes. However, only a handful were known as giants. But though they excelled in body size, they lacked in brain size. Some of the most well-known dinosaurs, like the Allosaurus and Stegosaurus, had very small brains, like me, which means it would have been nearly impossible for them to properly evolve into intelligent beings. Tell me about it. But in the late Cretaceous period, the T-Rex roamed the land. It had larger brains than its Allosaurus counterparts, which were millions of years behind. Even so, the T-Rex's brain only weighed just under a pound. A human brain is nearly 3 pounds. It might have been cool to see a T-Rex evolve into an intelligent being with opposable thumbs on its tiny stick hands. Contrary to popular belief, the T-Rex was actually quite slow, and a human could have easily outrun it. So, we know that these days, they wouldn't belong in any competitive sports that involve running. We know that dinosaurs could be herbivores and carnivores. But throughout their evolution, one thing remained the same: they had small brains. Other forms of dinosaurs were around too, such as long-legged and horned dinosaurs. Either way, they were on top of the food chain even when little mammals had cameo appearances. We have to consider that when the asteroid struck and wiped out dinosaurs, mammals took over the scene. If dinosaurs and mammals had shared the dominant position in the food chain and had followed a similar path in their evolution, then today's reality would be completely different than what we have now. Dinosaurs would have bigger brains and would compete with humans for the title of the smartest creature. One of the reasons why humans and parrots can talk is because of the strength and shape of our tongues. The evolved dinosaurs would have a different skull, shaped to fit such a tongue if they wanted to talk like humans. One of the reasons why humans made it to where we are now is because we evolved to stand upright to detect predators. This was one challenge we had to overcome in order to survive. But what would dinosaurs need to challenge if they were already the most dominant creatures? Some of the big-brained dinosaurs had long legs, which means they could run fast, detect predators, and grab food that otherwise would be beyond their reach. Their evolutionary path would be very different from that of humans, and maybe even more advanced. Their brains could have evolved into something impressive. They could turn out smarter than us and possess quicker reflexes. Imagine dinosaurs discovering gravity instead of Isaac Newton, or a dinosaur writing plays and poems better than William Shakespeare. Imagine dinosaurs possessing the creative knowledge to produce some of the finest art in history. Music and cinema would revolve around dinosaur culture, and fashion would look otherworldly. We would live in peace with dinoids, but we would certainly compete with them. The World Cup would feature dinosaurs and humans playing for their national teams, but clubs would be exclusively human or dinosaur. Some professions would be dominated solely by one species, and more physically demanding jobs would be taken by dinosaurs, like laborers and security guards. Eventually, dinosaurs would take over the world since they would be physically stronger than humans and would have better advantages than us. Humans, on the other hand, would need to figure out a way to keep up with dinosaurs. Mammals had a different path of evolution, where they never became gigantic super beasts as dinosaurs did. Instead, their brains developed and grew big. But even though humans are the smartest creatures on the planet, we don't have the biggest brain. Animals like orcas, whales, elephants, and other apes have bigger brains here. So why are we smarter than them? The answer is we don't know. The brain is the most complex organ we have, and we know so little about it. We don't even know exactly why it's so complex or why it behaves like that. Today's dinosaur descendants, like crows and parrots, have complex brains, which allows them to communicate, use tools, and even count. Bigger doesn't always mean better in this case. A parrot's brain is smaller than a cat's, but it's far more complex and intelligent than that of any feline out there. Some scientists argue that dinosaurs from the movies aren't 100% accurate, and that they used to have feathers. In terms of evolution, some small feathered dinos might have followed the path of primates. They might have evolved into a tree-dwelling primate that may also have followed the path of becoming another species of human.
Throughout history, humans have used tattoos to protect themselves against sorcery, claim membership in groups, declare their love, honor their loved ones, or simply express themselves. And it looks like tattoos are going nowhere, because as of 2022, 46% of the United States population has at least one. That's why it's not shocking that tattooing has taken the 6th spot amongst the fastest growing industries in the country. And it's safe to assume that this percentage will only go up. But have you ever stopped and wondered when this form of body modification came into existence and how it changed over the years? Let me tell you. Tattoos date back thousands of years. Have you ever heard about Otzi the Iceman? He's the 5,200-year-old mummy who was found embedded in glacial ice in 1991 in the Ötztal Alps. Yep, that's how he got the nickname Otzi. The reason I'm talking about him now is that he holds the record for the oldest tattoos in the Guinness World Records. He had 61 markings across his body that are considered to be tattooed by the experts. These markings are composed of vertical and horizontal lines which were created from fireplace ash or soot pigment. Otzi, however, was not trying to express his true self with them. When they examined Otzi's bones in detail, they noticed that there was age or injury-related degeneration on the tattooed areas of his body. This made scientists believe that his tattoos may have been related to discomfort relief treatments similar to acupuncture. That also explains the somewhat random distribution of those markings on his body. Experts also believe the fact Otzi had so many tattoos means that others in his culture knew about tattooing and that he wasn't the first person ever to have tattoos. Although Otzi's tattoos are considered to be therapeutic, evidence of figurative tattoos, which are images of real subjects such as animals and so on, were also discovered on 2 5,000-year-old Egyptian mummies. As well as pushing back evidence of the practice of tattooing in Africa by 1,000 years. This discovery also holds the importance of changing the belief that only Egyptian women got tattoos. However, other mummies with tattoos have been recovered from at least 49 archaeological sites, including locations in Greenland, Alaska, and the Philippines, which only suggests that tattoos were a worldwide thing. But despite all this evidence that shows the art of tattooing is ancient and universal, the exact date of when and where it began is unknown. There are written records that date tattoos back to 5th century BCE Greece. where they were used to mark criminals and enemies so that it would be easier to identify them if they tried to escape. Romans and Persians also used tattooing for the same purposes. Other cultures, on the other hand, had different uses in mind. In the Philippines, tattoos were symbols of tribal identity, kinship, bravery, beauty, and social or wealth status. They were also believed to have magical abilities and were done as protective talismans against any evil supernatural forces. Consequently, the process of tattooing was believed to be sacred. Therefore, it involved some rituals. For example, if an artist or a person who was about to get a tattoo sneezed before the tattoo began, this was seen as a sign of disapproval by the spirits. So the session would be called off or rescheduled, and once a tattoo was complete, a celebration usually would be held on its behalf. When it came to ancient Egypt, tattoos were originally used to show a dedication to a deity, and they were believed to convey divine protection. What's worth mentioning here is the fact that many of the tattooed mummies discovered in Egypt were female. One of those mummies came to be known as Amunet, the tattooed priestess of Hathor, who had a variety of tattoos on her body. When she was first discovered, experts initially thought that due to the placement of her tattoos, these were either done as a medical treatment for a lower body condition, or they were simply the markings of lower status. But in recent years, a further examination revealed that she was a person with high social status, so the previous theory was debunked. This discovery led some to believe that her tattoos possibly functioned as protection against the difficulties of pregnancy and childbirth. Now let's take a look at Japan's history with tattoos. Tattooing for spiritual and decorative purposes was widespread in Japan, and it actually extended back to at least 300 BCE. Some written texts also describe tattooing and other bodily markings to indicate social differences among Japanese people. By the 17th century, however, most criminals were tattooed as a mark of punishment. And by the mid-19th century, tattoos were banned altogether, and those who had them were viewed as lacking respectability, which in turn created a subculture of outcasts, who formed the roots of the Yakuza. But how did the modern and more expressionist role of tattoos in the Western world begin? James Cook was a British explorer and captain who was famous for his 3 voyages to the South Pacific, which took place between 1768 and 1779. During one of these voyages, he traveled to the Tahitian Islands, where he was introduced to the art of tattooing. When he landed on the island, he was surprised and impressed by the heavily tattooed men and women, and he wanted to make note of them in his logbook. So, to describe their body art, he used the term tattoo after hearing the locals use a word that sounded similar to it regarding their markings. Before that, tattooing was simply referred to as scarring, painting, or staining. Many of Cook's crew returned to England with tattoos from this voyage, which, in return, restarted a tattoo tradition among the sailors. They started using tattoos as a way to record their travels. For example, they would get an anchor tattoo if they crossed the Atlantic Ocean successfully, or a shellback turtle tattoo if they crossed the equator. This paved the way for the traditional style of tattooing. By the 19th century, although tattoos were still largely associated with sailors, they had spread to British high society as well. During the 1870s, they had even become fashion statements among some members of the upper classes, as well as royalty. The people who had them among the high society included British Prime Minister Winston Churchill's mother, Lady Randolph Churchill, Prince of Wales, the future Edward VII, and his sons, as well as several of Queen Victoria's relatives. It was even rumored that she herself had a tattoo of a tiger fighting a python in the area of her body that could easily be covered with clothes, just in case. This all led to tattoos becoming a mark of wealth by the late 1880s. In 1891, the tattoo machine was created by Samuel O'Reilly, who was a New York City tattooer himself. His design was based on a modification of Thomas Edison's electric pen, which was originally designed to help businesses with document duplication. It was also around the same years that tattooed women started to make appearances, though mostly in the circuses to entertain people. Although that industry eventually slowed down, by the 1920s, more women began to get tattoos as a cost-effective alternative to makeup, since products were so expensive at the time. In 1939, Mildred Hull became the first female to open her own tattoo shop in New York. It was around this time that the US introduced Social Security numbers, and many citizens got theirs tattooed on their bodies as a memory aid. However, despite these tattoos, decorative tattoos continued to be looked down upon. If you had a tattoo during the 50s or the 60s, you would still be viewed as a rebel or a criminal by the majority of people. In 1961, the New York City Health Department actually banned tattoos because they saw them as the cause of spreading diseases. The ban was not lifted until 1997. Today, tattoos are so common that even toys have them. So there's no ban, no stigma, no style or color restriction, and nothing to stop you from getting the tattoo of your dreams. Maybe except your mom.
At some point in its long and very interesting history, our dear planet Earth was sort of snoozing, just doing its planetary thing, spinning around the sun. And then, bam, life starts getting fancy. Plants and animals start strutting their stuff, showing off their complexity. Fast forward a bit, about 65 million years ago to be exact, and a cosmic disaster strikes, or at least that's what we presume. An asteroid probably smashed into Earth, wiping out the dinosaurs and other big animals. We can't pinpoint specifics about the asteroid, but we do know that it was extremely large and it crashed into our precious planet, creating a dusty mess that settled everywhere. You can still find remnants of that dust layer in sedimentary rocks today. If you dig beneath it, you'll uncover a whole bunch of fossils. These prehistoric creatures were living it up before the asteroid crashed the party. Think of it as the planet going on a cleaning spree, leaving a bunch of empty spaces waiting to be filled. And guess who took the opportunity? Mammals! These furry little critters were the ones to rise to fame. But why is it that this disaster became such a great opportunity for mammals? It's pretty simple, actually. With no big bullies around, they grew, multiplied, and had a population expanse. All kinds of mammals joined to fill in the blanks. Primates, rodents, basically, the whole furry gang. We're talking about placental mammals, marsupials, and even egg-laying mammals, adding some serious variety to the mix. We like to think of primates as our closest relatives here on Earth. What's their story? Well, around 63 million years ago, just a couple of million years after the dinosaurs' final dance, the primates decided it was time for a family reunion. They split into two groups, the dry-nosed primates, who became the cool monkeys and apes we know today, and the wet-nosed primates, who went off to become lemurs and aye-ayes, hey-hays. The fun didn't stop there. About 58 million years ago, the dry-nosed primates began their own little mission. One special guest called the tarsier, arrived on the scene, featuring big eyes that were perfect for late-night shenanigans. This tarsier took a different path from its primate relatives, embracing its unique niche and evolving separately. To this day, the tarsier is the only primate that feeds exclusively on meat. These little guys have a taste for insects, small birds, rodents, and even lizards. But that's not all that makes them unique. Their eyes are twice the size of their brains. Also, their heads can do a full 180-degree spin, just like an owl. Because of their features, the tarsiers are the true kings and queens of the night. With their superpower of ultrasonic tracking, they can spot their prey instantly. Plus, their legs and feet are like springs ready to launch them into action. They've got this special ankle bone called the tarsus, which gives them those epic leaping skills. Hence the name, if you were wondering. But let's leave these little critters to rest and get back to our story, shall we? About 55 million years ago, the Earth cranked up the heat, literally. This sudden hot pod was a bit too much for many deep ocean dwellers and plants to handle, and they bid their farewells. But hey, every goodbye is an opportunity for something new, right? The oceanic mammals known as cetaceans saw their chance and took it. They splashed into those empty niches, becoming the rulers of the sea. In this category of creatures, you can find the blue whale and the dolphin. A special primate guest made an appearance around 47 million years ago. Scientists now affectionately call the fossil of such a creature Ida. This little wonder caused quite a stir. Initially hailed as the missing link in human evolution. But here's the hilarious part. It turned out Ida was not one of us dry-nosed primates, but a cheeky wet-nosed one. Moving forward to 40 million years ago. This is when another big event happened in the primate world. The New World monkeys, our distant cousins, decided to take a different path and branch off from our lineage of Old World monkeys. They packed their bags and set off to conquer South America, where they're still living it up today. What's the difference between the two, you might ask? Well, one crucial thing that sets them apart is the fact that the Old World monkeys had nostrils that pointed downwards. Around 25 million years ago, another troop of apes entered the scene, and these guys had something special, the lack of a tail. These unique creatures would go on to become our closest relatives. We're talking apes and great apes, the cool gang who share a whole lot of genetic similarities with us. The first ape to break free from the monkey madness was the gibbon. About 18 million years ago is when this little acrobat swung into the picture. A few million years later, the great apes made their grand entrance too. Orangutans were the pioneers, venturing into the wilds of southern Asia. We're getting closer and closer to the present. It was 7 million years ago when the great apes took a major fork in the evolutionary road. One path led to our ancestors, the future Homo sapiens, and the other path led to chimpanzees and bonobos. These two primate branches remained united for a few million years before finally going their separate ways. 5.6 million years ago, a game-changing ape called Ardipithecus made its way into our evolutionary history. It had a special talent, bipedalism. That's right, this was one of the first apes to walk on 2 feet, probably making its primate buddies raise an eyebrow or two. The real showstoppers, however, arrived around 4 million years ago, the Australopithecus crew. These were the earliest members of the hominina hominina subtribe, our tribe. What made them so special? Well, probably the fact that they brought some serious tools to the game. Stone tools, to be precise. It seems that at some point in their evolution, these clever primates started using stones to make their lives easier. Now here comes a crucial turning point in our story. About 2 million years ago, our ancestors faced a food shortage. Survival of the fittest was the name of the game, and 2 strategies emerged. Group 1 went for stronger jaws, allowing them to chomp on tough foods like nuts. Group 2 had a different idea. They opted for weaker jaws, but bigger brains. They wanted access to a wider range of food options. Obviously, the bigger-brained group took the prize. And here's where our gang comes into play. Around 2.5 million years ago, a type of primate also known as handyman made its mark on history. These clever beings had larger brains and knew how to put those neurons to good use. About 1.9 million years ago, a new star emerged, Homo erectus. These creatures not only walked upright, but also had brains that were almost twice the size of the handyman's. They took the world by surprise, becoming the first of our direct ancestors to venture out of the African continent. They even knew how to tame fire. Approximately 700,000 years ago, the world witnessed a culinary revolution. The earliest evidence of cooking appeared. And around 500,000 years ago, our ancestors decided it was time to become a bit more fashionable, donning the first evidence of clothing. Our very own species came to be just 300,000 years ago. Told you we were late to the party. But the world was never the same after the appearance of Homo sapiens, the anatomically modern humans. Alongside our other relatives, we emerged, ready to conquer the world with our innovative minds and complex societies. The exact path of our evolution remains a bit of a mystery. But what we do know for sure is that Neanderthals joined the party around at some point too. As Homo sapiens flourished, so did our capacity for language. Modern speech is believed to have emerged almost hand in hand with our species. We started expressing ourselves, sharing stories, and shaping the world with our words. So, there you have it. It took 13.8 billion years of cosmic history for humans to make their entrance. Think about it. 99.998% of the time since the Big Bang, we weren't even around. Our species, Homo sapiens, is the toddler of the Earth's family, existing for just the tiniest fraction of the universe's timeline. Yet, in this blink of an eye, we've managed to unravel the entire story that led to our existence. The story won't end with us. It's an ongoing saga, still being written with every passing moment.
If you've ever hit your toe on a corner and felt that sharp pain, you know what I mean by why we have such delicate feet. Our feet are super sensitive. They're covered with this special hairless skin full of nerve endings. That's why it hurts so bad when we get a foot injury. Yet they aren't as delicate as we think. It's incredible how our feet are put together. They consist of 26 bones, 33 joints, and over 100 muscles, tendons, and ligaments. These are working together like a machine to let us move around. When we run, our feet work like springs. They must handle up to 7 times our body weight every time they hit the ground. Thanks to the clever arrangement of ligaments, tendons, and muscles, our feet store and return much of that force to the ground. By the way, they can also give us hints about our overall health. And every pair of feet is unique. No two pairs are exactly the same. They come in different sizes, shapes, flexibility, strength, and walking patterns. It's like our feet have their own personalities. But how have our feet come to this point? Researchers have been trying to figure out when and how early humans started walking upright. Well, they've been looking at feet, toes to be exact. Bipedalism, which means walking on 2 legs, was a major step in human evolution. It influenced a bunch of other changes in our lineage, like how we behave socially and develop our material culture. So, these scientists have been digging into the details of foot evolution to piece together the story of our species. The team has been checking out these special joints called metatarsophalangeal joints, which are placed between the long bones of the foot and the toe bones. In 2015, they found that, unlike in other primates, this type of joint in humans faces upwards, allowing us to extend it, which is perfect for walking on 2 legs. But apes and other primates have downward-facing joints, giving their feet a hand-like grasp. In their latest study, the researchers looked at fossils of primates and hominins, a human group, to see when this upward-facing joint first appeared. It turned out it had shown up about 4.4 million years ago in the lateral toes closest to the outside edge of the foot. Yet the big toe kept its downward-facing joint until much later, about 2.2 million years ago. So, it seems like early feet might have still kept some grasping ability while people were adapting to walking on 2 legs. The fully bipedal adapted big toe evolved relatively recently. But weirdly, our feet didn't leave much of a trace in the fossil record until recently. It's frustrating because understanding how our feet evolved is crucial to unraveling the story of human evolution, especially when it comes to walking on 2 legs. Our modern human foot evolved separately to suit different needs. The chimpanzee foot is more flexible, suitable for climbing trees, while the human foot is stiffer, perfect for bipedal walking. Speaking of feet, we might as well talk about the benefits of walking barefoot. It can actually bring us closer to our natural walking pattern, or our gait. That's a good thing, because it allows our body to move the way it's meant to. Shoes can make you feel like you are walking on clouds, but they can sometimes hinder certain muscle groups from doing their job and strengthening our bodies. But when you go barefoot, for starters, you have better control over how your foot lands on the ground. This helps with balance, body awareness, and even pain relief. Plus, it can improve your foot mechanics, which can positively affect your hips, knees, and core. It keeps your foot and ankle joints flexible and strong, thanks to the proper range of motion and muscle stability. And let's not forget about those uncomfortable shoes that don't fit right. Walking barefoot can relieve issues like bunions or hammer toes caused by improper footwear. Have I mentioned stronger leg muscles? Yep. Going barefoot can give your legs a nice workout, which is excellent for supporting your lower back. So, kick off those shoes and let your feet breathe the next time you find yourself on soft grass or sandy shores. Your body will thank you for it. Not just our feet have evolved over time. Our ancestors had bigger brains too. It means our brains have shrunk. Researchers looked at cranial fossils and discovered that our brains started downsizing about 3,000 years ago. Agriculture took the stage around 10,000 to 5,000 years ago, and civilizations sprouted like mushrooms after a rainstorm. There were sprawling cities, architectural wonders, and even some fancy writing thrown into the mix. The connection between brain size and IQ isn't as straightforward as it seems. Many critters rock brains that make ours look dumb. A massive study with thousands of brain scans and IQ tests revealed that brain size and IQ are like two friends at a party. Sometimes they dance together, and sometimes they go solo, with no strict correlation. It turns out some ant societies are like a mirror to our own, complete with their own version of farming and teamwork. And ants with bigger societies have bigger brains, except when they get into the whole farming gig. But smaller brains might be a cooler choice when teamwork gets super complex. Maybe the invention of writing around 2,000 years ago also played its role. It's like the ultimate external brain. You write stuff down and boom, you have ideas at your fingertips. It's like your brain is outsourcing its memory power. Here is a recent thing you might want to consider, especially if you are a gamer. Some streamers have made an unexpected discovery after spending countless hours wearing headphones. There's a headphone-shaped groove on top of their heads. Let's bring in science before we all start imagining our skulls reshaping like Play-Doh. It's highly unlikely that headphones are engaged in skull remodeling. According to experts, giving a human skull a makeover takes 297 pounds of pressure. So, what's really happening here? The headset is just giving a friendly nudge to our softer bits and pieces, causing a temporary dent that can be smoothed away. Another thing is about your phone holding style. Do you use your pinky to prop up the weight of your device, forming a sort of locked-in position? Ever wondered if this way of gripping might be causing some issues to your hand's well-being? Now, as smartphones keep getting bigger and better, a funny thing is happening. More and more people start noticing this smartphone pinky issue. You might have noticed a tiny groove forming on your pinky from being a loyal phone holder. Let's set the record straight once and for all. Holding your phone this way for long periods can actually bring some trouble. A common issue here is a trigger finger. Basically, bending your small finger to cradle the phone can cause it to get stuck in a flexed position, especially if you've got a trigger finger lurking beneath the surface. It's like a tiny finger traffic jam. Treatment often involves injections or minor procedures to release the tendon tangles. Your wrist might also decide to join the hand-hurting parade. This one causes numbness and tingling in your thumb and other digits. Plus, when your elbow is flexed, like when you're holding your phone to your ear, it can put pressure on the ulnar nerve, leading again to numbness and tingling in your ring and little fingers. Interestingly, apart from a tiny muscle called the arrector pili, our fingers don't have muscles. So how in the world do we wiggle them? The muscles in our forearms are like puppeteers pulling the strings behind the scenes. These muscle maestros initiate finger movements, and here's where the real magic happens. Those movements are like secret messages zipping down to our fingers through tendons. Think of tendons as those trusty messengers delivering commands straight to our fingertips. How's that for finger wizardry?
Can you imagine that all modern humans came from about 1,000 people? Around 800,000 to 900,000 years ago, almost all of our ancestors disappeared, leaving about 1% of the population behind. So, what the heck happened? The Earth often goes through glacial cycles, things that we call ice ages. Back in the past, they were pretty mild and happened regularly, about every 41,000 years. The ice ages happened because of the Earth's axis. Our planet is slightly tilted at an angle, which is why its axis isn't straight up. Over thousands of years, this tilt has changed a bit. This teeny tiny shift completely changes how much sunlight we receive, especially at the poles, and leads to incredibly strong cold or warm periods. About 2.6 million years ago, when early humans were settling in on Earth, the Pleistocene epoch started. That's the era we traditionally call the Ice Age, the one from the movies. Large ice sheets completely covered parts of North America, Europe, and Asia. It wasn't constant ice everywhere all the time. These glacial cycles came and went, and sometimes ice sheets melted for a while. But overall, things were still much snowier and colder compared to now. We can still see the evidence of this from back in the day. Those glaciers carved out valleys and left behind some awesome things like moraines and fjords. And since sea levels were super low, a huge part of the world was land. This allowed people and animals to travel between continents and spread everywhere. It was the time of the megafauna. You all know about it from the movies. Woolly mammoths, saber-toothed cats, giant ground sloths, and mastodons. Our ancestors had some fun times hunting all those giants. Now, humans didn't come from one lineage. It wasn't like monkeys slowly turned into humans. We also consisted of many species: Homo erectus, Neanderthals, and so on. But only one species, Homo sapiens, survived and turned into modern humans. Harsh conditions forced them to get smarter. They learned how to make tools, clothing, and shelters to survive. They became hunter-gatherers and invented fire, which turned out to be super useful during the Ice Age, you think? But they had no idea what horrible change was coming. Something disastrous happened about 800,000 to 900,000 years ago. Humans faced a drastic population crash. Only 1,280 people survived, give or take. Some 99% of early humans were wiped out, and this tiny 1% was lucky enough to become our ancestors. This almost extinction, unsurprisingly, was the climate's fault. It was the Middle Pleistocene transition. The Earth's orbit around the Sun changed its shape a bit. Carbon levels dropped. A lot of stuff was happening, and the Earth's climate was going wild, becoming incredibly cold and dry. The seas suddenly got chillier, and Africa and Eurasia experienced horrible droughts. Looking for food was almost impossible. Scientists learned this by taking the DNA of about 300,000 people from all around the world. They used a new method to help them map the history of human evolution over 1 million years and learn more about it. No wonder we can barely find any fossils from that time. There was almost no one around. What's interesting is that before that happened, most apes had 24 pairs of chromosomes. But because the population became so small, 2 sets got fused together, and we ended up with 23 pairs. This was the final straw that separated us from other apes. Chimpanzees, gorillas, and orangutans all have 24 pairs, but our fused one became known as the human chromosome. Like a ripple effect, this little thing influenced our brain side, helped us start walking on our twos, and even form language. It took humans about 100,000 years to recover from this catastrophe. Only after all that time, they started spreading around again. Isn't that insane how we managed to go from 1,000 to 8 billion people? In any case, the Ice Age finally ended about 11,700 years ago. The warm period, called the Holocene, began. As things got warmer, human civilizations finally began to develop. 5,000 years ago, it was ancient Egypt, then the Indus Valley Civilization, ancient China, and others. And while we've been thriving for a while, there's one catch. The Middle Pleistocene transition changed the length and intensity of glacial cycles. Before the transition, sure, there was the Ice Age, but the cold was milder, and the glacial cycles were shorter. Things got covered in ice sheets about every 41,000 years. But after the transition, the glacial periods became longer and more severe. These cycles started following a new pattern. Although they happened every 100,000 years, they were super intense. Ice sheets grew large, even extending to the south. So from now on, ice ages that will continue to happen in the future will be a bit different. The next one should be at least 50,000 years from now, maybe longer. It's good for us because it'll occur later. But at the same time, the consequences will be stronger. What our ancestors went through is called a population bottleneck. That's what we call a sudden and huge reduction in the size of a population. Usually it happens because of things like earthquakes, floods or droughts, fires, and even human actions. Just a few people survive, and only they can pass their genes to future generations. And we've got plenty of such bottlenecks in history. Our modern species, Homo sapiens, originally lived in Africa. Around 60 to 80,000 years ago, a small group of them left Africa and spread across the world. It wasn't on a whim, though. They had to move somewhere because of the droughts and huge climate problems in Africa at that time. They had to go look for food and find new places to live. They traveled through the Middle East, moving into Europe and Asia, and eventually reaching Australasia and the Americas. They quickly settled across different continents and started mixing with local human-like species, like Denisovans and Neanderthals. But there was a problem. Originally, the African species were super genetically diverse, but since only a small part of them decided to move out, they carried just a bunch of these diverse genes with them. Unfortunately, this caused a bottleneck for everyone. Human-like species from other parts of the world became less genetically diverse. Since they had a smaller gene pool, they became more vulnerable to all the harmful stuff. The African population also had a drop in genetic diversity. But at least humans managed to survive. Although eventually, non-African populations really dropped, and there were no Neanderthals or Denisovans left, only us, Homo sapiens. That's why we can say that all modern humans came from Africa. Early humans sure had it rough. About 74,000 years ago, they went through yet another disaster, the Topa catastrophe. But keep in mind that all these things are just a hypothesis. It's not certain whether it actually happened. Now basically, scientists think that there might have been a supervolcanic eruption at Lake Toba in Sumatra, Indonesia. This volcano going crazy was an absolute catastrophe for Earth's climate and humans. The eruption was one of the most powerful volcanic events in the last 2 million years. It spewed out from 670 to 1,500 cubic miles of lava and volcanic stuff. Just so you know, there are about 3,100 cubic miles of water in our planet's entire atmosphere, and this eruption had almost half as much lava. This horrendous disaster led to the formation of Lake Toba, a massive caldera lake in Sumatra. It also spewed out tons of ash and sulfur dioxide into the atmosphere. This caused the so-called volcanic winter, which means that while it's not actually winter, the temperatures drop and the planet is freezing because all these ash clouds are blocking the sunlight from reaching the Earth. This event affected climate patterns for years to decades. This also most likely sped up the arrival of the next glacial cycle. Luckily, humans are crazy good at surviving. The global human population was reduced to a few thousand people yet again, and they still managed to overcome this.
Hey there, curious history buffs! Have you heard the legend of the ancient race of giants of Nevada? Yes, I'm talking about actual giants that allegedly lived thousands of years ago. Now I know what you're thinking. Giants, really? Well, archaeological finds add fuel to this debate too. And here's where it gets interesting. Lovelock Cave was indeed used as a burial site, and some of the remains found there are much larger than average human bones. The cave is by the Humboldt Sink in western Nevada. It was once part of an enormous lake, which eventually dried up, leaving a number of smaller ones, including the Humboldt Sink. The cave became the home of the Site-Ka tribe. According to the legend, these red-haired giants were so big that they had to be buried in the cave itself. Indeed, later on, archaeologists discovered 8 to 10 foot tall skeletons. This legend started to unfold when a mining engineer named John T. Reed talked to the locals in 1886. Once Reed saw the cave, he knew he was onto something. The news spread soon, but the cave was attracting another type of attention too. The deposits of a fertilizer known as guano were discovered inside the cave. So a mining company began excavating the precious resource in 1911 and soon shipped more than 250 tons of the fertilizer to San Francisco. Unfortunately, some of the human remains and artifacts were neglected and lost in the mining process. This led to an official excavation in 1912 and 1924. After the top layer of guano had been mined, strange objects started to surface. Around the area, the earliest evidence of human habitation dates back about 4,000 years. The Lovelock culture lasted for some 3,000 years, and they left us with 10,000 stunning artifacts. The pits in the cave were like a series of time capsules hidden at different depths. Archaeologists determined the age of each pit by its depth. It turns out that many different groups used the cave for storage over a really long time, and the things they stored there give us a really cool glimpse into their cultures. It's like a giant ancient storage unit full of hidden treasures. What have the researchers found besides the giant bones, you might ask? Some other bodies were mummified using a method similar to the one applied by ancient Egyptians. These remains also had something in common with the bodies discovered as far south as Lake Titicaca. Both mummies had some red hair, yet there are scientists who believe this reddish hue is the result of the interaction with the environment in which the bodies stayed. So, while the story of the red-haired giants may be a wild and intriguing tale, not everyone is convinced. Some experts believe that the bones found in Lovelock Cave are simply the remains of prehistoric animals, like mammoths or sloths. But others insist that there's something more to the story. Other relics, such as finely crafted baskets and exquisite duck decoys made from tule fibers, were also found there. In any case, this cave is worth the attention it gets. By the way, you can still visit this cave today and see the pits of different depths with your own eyes. But let me tell you one thing. It's in a hot, dry, and isolated place. Archaeologists have made another discovery that seems to be straight out of a legend. They think they found the palace of the one and only Odysseus, who was the legendary Greek king of Ithaca and the hero of Homer's epic poem. Move over, Indiana Jones. We've got some real-life adventure happening here from around 1300 BCE. Apparently, this is the only palace mentioned in Homer's epic poems that hasn't been found. The excavations have been made on the Ionian Islands, and the view from the ruins found on the island of Ithaca are exactly as described in the Odyssey, says the professor who led the excavation team. Known to the ancient Romans as Ulysses, the Greek hero took 10 years to return home to Ithaca after the fall of Troy. For many years, Homer's other epic, called the Iliad, which tells the story of the protracted siege of Troy by the Greeks, was regarded as a myth too. But then, in the 1870s, Troy was rediscovered in modern-day Turkey's Çanakkale city. So, if they found Troy, who's to say they couldn't find Odysseus's home? The researchers were following Homer's words as a roadmap. The excavation site has a building complex with 2 levels. It has important finds, such as storerooms and workshops, a complicated drainage system, and fragments of pottery. It also has a well from the 8th century BCE, which is around the time when Odysseus is believed to have been the king. Yet, not everyone is convinced that the team has actually discovered the home of Odysseus. A British researcher named Robert Biddlestone insists that Homer's description of ancient Ithaca isn't very similar to the island that now has its name, and that Odysseus's kingdom was actually on the Isle of Cephalonia. However, Italian archaeologist Adriano La Regina might have a more realistic approach to this debate. He says that whether this find has a connection to Ulysses or not, what's more important is the discovery of this royal palace. Once upon a time, in a land far away, the Klamath Indians spread a legend about the creation of Crater Lake. Okay, maybe this land is not that far away, and it still exists. You can find it in south central Oregon, in the western United States. Anyway, the legend has it that this lake was formed in a vicious battle between two volcanoes, Mount Mazama and Mount Shasta. Then the spirits of earth and the sky, which are Lao, who ruled the below world, and Skell, the chief of the above world, joined the fight. It turned into a geological drama. During the battle, darkness veiled the land. The fight was over when Mount Mazama collapsed and sent Lao back into the underworld. Then the rain filled the pit and created a lake in the place where the mountain had once stood. Flash forward to our time. Scientists have discovered that Mount Mazama did erupt 7,700 years ago. Artifacts found in the area prove that the legend indeed contains some details about the explosion. The tale says that red-hot rocks were flying through the sky. This happened during the volcanic eruption that caused the mountain to collapse. This created the volcanic caldera, which later on got filled with water. What makes this legend came true story unusual is how long it has existed. According to researchers, these types of verbal stories lose their credibility within 600 to 700 years. That's why the legend about the creation of Crater Lake is so unique. So many generations, for hundreds of years, have been accurately passing down the information. This volcanic crater lake is now in a national park. It's famous for its deep blue color. The water in it is extremely clear. If you visit it today, the water you'll see won't be the same as for someone who will visit the place 250 years later. Because there are no rivers flowing into or out of the lake, the existing water evaporates and the lake gets filled again by rain and snowfall. Basically, every 250 years, the water is replaced. Plus, this lake is almost 2,000 feet deep, which makes it the deepest lake in the United States. Swimming is okay in the lake, but there's only one legal and safe trail to get to the shore. There are other activities, such as fishing and boat tours. Shared human experiences, such as birth, marriage, and aging, may explain why certain tales are shared globally. Similar struggles and obstacles faced by humans around the world generate similar themes in traditional stories about love, parenting, and mortality. So, do you have legends or tales you've heard of from your grandparents? Who knows? Maybe your ancestors too witnessed a cool historical event.